Okay, 3, 2, 1. Hello world! Hi! Welcome back. So nice to see you today. So, disclaimer, if you think that I'm wearing lipstick, you're almost correct because I'm wearing lip balm since my lips are cracking. And today we're going to do a marathon of probably 5 hours straight, or 4:30. Let's see. It depends on you guys. If you're really tired after 4 hours and 30, we'll stop there. Otherwise, we can go with 5 hours. Why is that? Well, because last time it was raining in Turin, and apparently this yielded a power outage in the whole city or in the whole suburb. So we had to end the lesson abruptly 1 hour before the end. So now we're going to recover this day. And I hope that's fine for you, since 5 hours is a long time, and most of the people that are interacting with me usually are from Europe, in my same time zone. You probably want to also have lunch in mid-time. So we could probably do something like 2 hours and a half, then a long pause, a long break. Long meaning 15, 20 or 30 minutes, it depends on what you prefer. And then we can move on. So it's not exactly 5 hours straight. I don't want you to die on me. I can skip lunch and I can speak straight for 5 hours, but I'm not expecting this from you. So last time we were looking at data types, right? And data types is just a rehearsal of all the primitive types that we already discovered. So strings, numbers, booleans, etc. And we found out that strings, numbers, etc. have more behavior than what we expected. In fact, strings, for example, have methods that you can apply, that you can invoke on them. So to uppercase for the string turns everything to uppercase, or the number can be turned into a string with a fixed number of digits, with this to fixed and the number of digits. And numbers, there are so many numbers there. We can create numbers in exponential notation, in hexadecimal, octal, binary, and we can convert things into strings and vice versa. We've got the math object, which we already know, and it has so many properties and methods that we can use. We also know that there are some quirks in numbers. For example, 0.1 plus 0.2 is not exactly 0.3 because we have some rounding problems there, and they are not only pertaining JavaScript, they are in almost every programming language. Hi Tiago, good morning. So good to see you. How are you today? And well, we also know that numbers have the special number called infinity and the special number called not a number, which is a number, but it's not a number. Then we also have parse int and parse float, which are still relevant because you can add a second parameter which allows you to specify the base in which you are parsing that integer or that float. Hi Angelo, good morning folks. And so many other things that are related to numbers and so many things that are related to strings, but most of them we know them already. Then we started looking a little bit at arrays, and now we start also probably understanding a little more some things about the strings, because strings have a length property, and strings you can retrieve one character from the string by using square bracket notation, like str square bracket index. This is a behavior that is really similar to arrays, and in fact in lower level languages such as C, there's no real difference, if I remember correctly, between a string and just an array of characters. In fact, I don't even think that there's a string type in C, in the C language. I think that it's just an array of characters, but I could be wrong. Let me check. C language string. Maybe I'm wrong. String in C language. No, I was right. It's not exactly a string. It's an array of chars, an array of characters. So in lower level languages, there's not much difference between arrays and strings. In higher level languages, strings have a special behavior because we want them to be single quoted, double quoted, with backticks, and we want to use methods that pertain only strings, like to uppercase, to lowercase, include, starts with, ends with. We also saw Splice, which creates a new substring with the begin index and the end index. And we also have many other methods, but all these methods from strings always create a new string. You can never change the string in place. Strings are immutable. And finally, we can go back to arrays. So we already saw that arrays can be seen like objects, special kind of objects, because objects are a key value pair structure, like this one, right? An object is curly braces, something that has key value pairs. An array could be seen similar because every single value is at a specific index, and the index is unique. The index can be 0, 1, 2, and you can never have two indexes which are 1, both of them. So if you wanted, you could do even something like const r_obj, a hybrid between an object and an array, which is 0 value 1, and 1 is value 2, and 3 is 42. This seems like exactly the same as this array here, or well, the same structure as an object. But there's a small difference. If you remember correctly, in an object, every key must be a string. So if you write 0, this actually means string 0. So there is a difference between writing arrays and writing arrays as objects. And this difference, a huge difference for starters, is that the keys in the array are actually numbers, they are not strings. So this is not exactly the same thing. Arrays can be used whenever you don't care about specifying a name for each property, but you care about their position, their ordering. You want them to be exactly in that order, while the object doesn't usually guarantee the order of things. For example, if I swap these two around and I specify first the key 2 and then the key 1, I don't have any guarantee that key 1 will still be after key 2 if I inspect the object, if I iterate over the keys of the object. We could probably try too. So if I have this object, which has key 2 and then key 1, when I inspect the object, yeah, it actually preserves the order. But sometimes it doesn't. And there is some, of course, some rationale behind this, which I don't remember. So JavaScript objects, key ordering. There must be something like, let's see. Oh, Stack Overflow. Does JavaScript guarantee object property order? If I create an object like this, will the resulting object always look like this? The iteration order for objects follows a certain set of rules since ECMAScript 2015, but it does not always follow the insertion order. Simply put, the iteration order is a combination of the insertion order for string keys and ascending order for number-like keys. Okay, so if I start adding things to this object, for example, object of 1, is there something strange happening? Yes, because the 1 now happens before. You see? So yeah, there is no guarantee that you will have all the elements, all the properties in the order in which you put them in the first place. While arrays instead guarantee this thing. So you put them in an order and they will always stay in that order. And then you can just access properties of this array, items of this array, with bracket notation. So R of 0, R of 1, R of 2. There's no way you can do dot notation. There's no R of 0. You cannot use it like this. And that's it. Arrays can be inside of objects. Objects can be inside of arrays, but you discovered this by yourselves. So let's move on to something more interesting. One thing that I really like about arrays in JavaScript and also in other high-level languages such as Python is that arrays can do a lot of things, and in other languages arrays are instead very limited. For example, in Java, which is a high-level language, but not as high-level as JavaScript in this case, in Java and probably also in C#, the array is a structure that has a fixed length. So you have to come up in advance with the length that you want to build the array with. For example, I want an array of width of length 10, and then you can fill the array with items inside. But if you need a longer array, well, you cannot just elongate this array. You have to create a new array, which is longer than the first one, and you have to copy all the elements of the first array into the second one. So, as you can imagine, it's a lot of low-level work because the arrays have a fixed length. That's why in those programming languages, Java, C#, etc., we also have objects that represents an indefinitely long kind of array, and they sometimes also have different behaviors. For example, in Java, if I remember correctly, there is the concept of vector, which is similar to an array, but it can be a little longer. We've got the concept of list, but what kind of list? We've got array list, we've got linked lists, we've got queues, we've got stacks. Every kind of object has a specific purpose. The cool thing about JavaScript is that the array has every one of these purposes. So you just need to know one data type, array, and you can do anything you want with it. But still, let's see how an array works as, for example, a queue or as a stack, because that's really interesting and that's really useful. So, an array, as you can imagine, is just a collection of elements in a specific order. And if you imagine those elements stacked one on top of the other, you can easily push one element on this stack by just putting it on top of the stack. And you can remove an element from the beginning of the stack by just removing from the bottom. These are the terms push and shift. When you push, you put an element on the stack, and when you shift, you remove an element from the beginning of the stack. Well, this is how queues work. Queues have this behavior, which is usually called first in, first in, first out, yeah, queue, FIFO. Let me check. I don't want to tell you stupid stuff, but I think it's like this. Yeah, okay, yeah. Queues are first in, first out. Why is that? Well, because if you see the queue, well, this is a horizontal queue, but it's exactly the same. So if you put one element in the queue from the left, this element will shift towards the end of the queue, the more elements we put. And when we remove the first element, the last element in the queue here, it is the first element that we put. So this is like, maybe you already know the term buffer. Buffers are queues. A queue is a line of elements or people, and the first one that arrives is the one that gets served. So also the first one who can go out of that queue, okay? Very democratic. But sometimes we also see arrays and use arrays as stacks. So if you want, you can see the queue as horizontal and the stack as vertical. The stack is like a stack of papers. So you push things, putting them on the top, and you pop things by removing them from the top. The stack can be useful sometimes. Well, for example, if you want to represent a stack of papers, you don't want to remove paper from the bottom because it's more difficult. You want to remove it from the top. Maybe you have a list of tasks that you want to accomplish, and you put them on a stack, and every task that you have on the top of the stack, you unstack it, you pop it, you work on it, and you put it somewhere else. Okay, so these are two kinds of ways we can use arrays: as stacks, this one, or as queues. And as you can see, there are some specific terms that you have to know: push and shift, and then push and pop. There's also another method that will be explained later on, which is called unshift. And unshift is just pushing, but not on the top of the stack. It's pushing right at the bottom of the stack. And it's exactly the opposite of shifting. If you shift, you remove the element from the bottom of the stack. If you unshift, you insert the element at the bottom of the stack, okay? And these are methods that we can call on arrays. It's pretty easy. If you have an array like fruits, an array of apple, orange, and pear, and you pop, well, when you pop, you can stop. But when you pop, you're removing the last element of the array as if it was a stack. So fruits pop changes the original array, and the new array of fruits is apple and orange without the pear. Okay? I think that fruits pop is also returning something, if I remember correctly. And I think that pop returns not the element that is being removed, but the length of the array. Let's find out. So const fruits is equal to orange, apple, and pear. Do you know the show The Annoying Orange? I just recalled that show. If I do fruits pop, oh, okay, it returns the element that is being popped out. And then the array of fruits is orange and apple. So shift and pop are like delete. Yes, they are like delete, but as you can see, it's not deleting any index you want. You are just deleting from the top or from the bottom. Then we will also see if there is a way to delete items from the top of the bottom or the bottom, from any index, not on the top of the bottom. As you can see in JavaScript, the array changes its length. The array had a length of 3 and now it has a length of 2. This is a behavior that is very common in other languages when you're dealing with lists and queues and stacks and array lists and linked lists, but not with arrays. Arrays in Java must have a fixed width, and the only thing that fixed length. And if you remove an element from the array, you're just putting a null inside of the array. So you have an array of 3 elements, but the last element will be null. Or you have to completely change that array, maybe copy all its contents into a new array that is only length 2. Now let's try to push. Fruits push. Let's put kiwi. If I push kiwi, it gives me the new length of the array, and I will see that now we've got an array of length 3. Orange, apple, and kiwi. We can try to shift. And if I shift, it gives me orange, which is the element that was removed at the beginning of the array. And now fruits only has 2 elements, apple and kiwi. But I can also unshift, which means pushing an element, but from the bottom of the stack. What other fruit we want? Let's do pineapple. Or, you know, the more international one, ananas. Because everybody calls it ananas, but not the English and the Americans. And now the new array has length 3. Well, the array now has length 3. It's not a new array. It's the same array as before. And now we've got the ananas or the pineapple shifted, unshifted, so placed, inserted at the beginning of the array. Okay? One small thing about the performance of these operations. Well, if you think of an array, and the Spanish they call it piña. Oh, right, piña colada, of course. Okay, that's nice. Yeah, not everybody calls it ananas. I'm sorry, that was a stupid assumption. Thanks for disproving that. So, if you think of an array as a stack, as a vertical stack, you can imagine that pushing things on the array is actually pretty easy. You just place things on top of the array. And popping things from the array is also very easy. You just remove whatever is on top of the array. But if you shift or unshift from the bottom, it's actually pretty complicated, especially if you have a long stack. If it's a heavy stack, removing things from the bottom or even inserting things from the bottom is actually pretty heavy. Well, the same goes with in computers, but not because arrays are actually heavy, but because internally what happens is that when you push an element on the array, the array just increases in size by 1, and it now hosts the new element. But if you shift the element from the bottom of the array, well, then in that case, the element, the array should increase in size. It should shift all the elements one place, one seat. So if you have, let's say, an array that has, let's do it in pseudocode. If you have in position 0, you've got hello. And in position 1, you've got world. Then when you push something, you just say, okay, in element 2, I'll have exclamation mark, and that's it. And if you want to pop, you just remove the last element in the array, and you're done. But when you shift something, the array will have a new element in position 0, like hey, and all the other elements should be shifted by one position, right? So that's why it's called shift, because whenever you place something from the start, you have to shift everything else one place on the right. And the same goes with unshift. If I remove the first element from the array, well, I don't just need to remove this element, I also have to shift the position of all the other elements on the left by 1, okay? So that is intuitively why shift and unshift are a little slower in performance than push and pop. And that's why you should prefer, if you can, to always use push and pop instead of shift and unshift. But of course, there are some cases in which you really want to shift or unshift, so that's fine. Okay, so yeah, they already had a visual representation. If you have apple, orange, pear, and lemon in position 0, 1, 2, and 3, and you try to remove the apple, then you will be left with a blank cell, and then the array internally will shift or unshift everything on the left in order to have every single cell occupied by something. With pop, it's actually pretty easy, because you've got the lemon position 3, you just remove the lemon on position 3, and that's it, okay? So, how can you loop on arrays? Well, you can loop the usual way. So many times we did this kind of loop, and you access the nth element of the array with the square bracket notation, r of I. There's also this new kind of loop that we have in arrays, and I never use it. But it's like this: let fruit of fruits. For of. This is the for of loop. Not to be confused with for in. For in is used for objects. And if you try to use it for arrays, it actually works. But it's probably not a good idea. It's actually a bad idea, because there are potential problems with it. I don't think it's important to know what are the problems right now. If you want, you can just read these reasons why you don't want to use for in instead of for of for arrays. But in general, just remember, for in is the historical for each loop that can be used in objects. We didn't have such a loop for arrays. Starting from ECMAScript 6, if I remember correctly, now we have the for of loop for arrays. Please don't confuse them. You can try and do experiments on using the for in on the array. I should have the fruits array now. And this is still going to work probably, but it has some side effects. Oh, okay, this is not working because this is giving me the keys of fruits. So fruits has 3 fruits in position 0, 1, and 2. And of course, if I'm iterating the array as if it was an object, it's actually behaving like fruits was an object. So if I want to get the item, I should do something like fruits of key, just like with an object. Maybe writing it correctly. And now I've got the elements. And I can probably do something similar with objects, maybe. Let's see. Const obj is equal to, let's create a stupid object like key1, value 1. I'm just playing around and doing experiments instead of just reading the reference material and learning it by heart. I want to make sense of what I'm doing. So this is an object, and if I try to do a for of, let's see what happens. Maybe it just gives an error, or maybe not. Console log key. Well, this is probably not a key. Ooh, obj is not iterable, so you cannot use a for of in an object. You can use a for in an array, but I wouldn't suggest to do it. Instead, you can use for of on fruits, and this actually doesn't give you the key because there's no key in an array. There's just the values, the items. So I'm going to call it item, and this just works, as you can see. And now we've got the usual problems with WebSockets. Okay, I'm going to my website that doesn't mess around with all these sockets things. Okay, another thing which can be quite strange, you can use const here, if I remember correctly. Yes, but I haven't created the fruits array yet, so I have to create it. Here it is. And yes, even though we are iterating over an array of items, the item can be const, because at every single iteration of this loop, this variable is actually created anew. So you can use const. And as you know, I love constants more than variables. So whenever I can, I always use constants. Okay, now they have a word about length, and yeah, this is a way to show you how you can mess up with arrays pretty bad. So it's actually pretty important. For example, you have an empty array of fruits and you put the apple at position 123. This automatically creates an array that is long 124. Let's see the shape of it. So let fruits is equal to, I don't think it's working. Okay, let fruits is equal to an empty array. Okay, and then I'm gonna say fruits of 10, let's put 10, is equal to apple. What is fruits like now? Ooh, there's something really strange here. It's not an array with 11 elements and all the elements before apple are undefined or null. It's an array which contains empty spaces and familiar faces. So that's a very strange thing that happens only in JavaScript. Now we've got null values, which are common in every single programming language. We've got undefined values, which are specific to JavaScript as far as I know. And we even have empty cells in arrays, which are not null and are not undefined. That's actually a pretty strange situation that you never want to incur into. But it happens. And it happens especially if you misuse arrays. For example, if you want to add an element on the array, please don't use this. I even thought last Saturday that this was not supposed to work. And it doesn't work in some scenarios. For example, in other languages such as Java, where the array has a fixed length, you cannot do this, because if the array has length of 0, then you will incur into a so-called index array out of bounds exception. This is what happens in Java. Index array out of bounds exception. It's an error that occurs when you're trying to access an element in an index of the array that is outside of the bounds. If the array has length 0, you cannot do anything on position 10 in Java. In JavaScript, you can do it, but as you can see, strange things happen. The array increased its length to be 11 items long, but the elements before the item that you inserted are not undefined or null. They're just empty spaces, which are very strange and difficult to use. And you should never use them, actually. So if you want to push something in the array, it's much better to do push. What happens now? Now we've got empty, apple, apple, but we still got these empty spaces, which is kind of strange. What the documentation says is that you can even change the length of the array, but please don't do it. You can do fruits now has length 2, which is actually true because we've got 2 elements and then just empty spaces. But what happens when I do this? Now the array changed so to have just those 2 empty spaces. So it just shrinked into the first 2 empty spaces here. And what if I start with a full fruits array? So let's go with, 3 elements in an array. If I say fruits.length is equal to 2, well, this is what happens. We've got an array of length 2. And the element was removed, but it's actually strange. I never used this, and it's quite dangerous to shrink the array this way. You probably want to remove the items in a specific way, not just truncate everything. And what happens if I go back with the initial length? Fruits of length is equal to now 3 again. Now fruits, again, contains orange, apple, and this empty cell, which is not null, it's not undefined, it's an empty cell. And it's very, very strange when you try to iterate over the array, etc., etc. So don't create empty cells. Okay, you've got also the constructor new array. Never use it. Use only the square bracket literal because it's much better. So don't worry about that. You can create an array of arrays. And when you create an array of arrays, this could represent a grid, a matrix, because every element of the array can be seen as a row, and every element inside of the inner array can be seen as a cell in the column. So this looks like a matrix, 1, 2, 3, 4, 5, 6, 7, 8, 9. So now you're able to create, I don't know, the 2048 game or any chessboard style game. You can play chess with a matrix like this. You put specific symbols in every cell of your board, and those symbols represents, I don't know, the rook, the queen, the king, the pawn, etc., etc. And if you want to access a cell of the matrix, well, it's pretty easy because you go with, for example, matrix 1, which will give you the second element of this array, and then again of 1, which will give you the second element of the inner array. So matrix 1, 1 is 5, the central element. I hope this makes sense to you. If it doesn't, I can do some examples and show them better to you, but I think it's pretty straightforward now. You tell me. No worries. You will not be publicly shamed in the public square if you think that this is strange and you never saw it before and you have difficulty understanding it and you want some more examples. Really, no worries. I reached something like 244 followers. I don't know how many are actually watching my videos, but thanks anyway for watching. And I don't have feedback from most of them. So you guys who are actively writing on the chat are the representatives of all the lurkers out there that feel ashamed or just don't bother writing and giving feedback. So your feedback is really, really important to me because it's the feedback of the people. It's the feedback of all my viewers. Okay, don't see anything going on in the chat, so probably everything is cool. A matrix is a multi-dimensional array, or you can just call it a grid. And the grid is just an array of arrays. So you can inspect the cells by going into the rows and into the columns. So if you want, you can even go back to your shapes exercises, and instead of concatenating strings, you can probably try to push characters into an array and then merge everything together. So many things that you can do with arrays, so many things you can mess up with arrays. For example, you can turn the array into a string and it will look like a comma separated string. Never done this. You can try to mix. It doesn't work for me with alert matrix 2, 3. Okay, if you tried with exactly this matrix here, I can understand why it's not working, because 3 is an index that is out of the bounds. The array here, the outer array, has 3 elements, which have index 0, 1, and 2. And the inner arrays are arrays of 3 elements, which have index 0, 1, and 2. So there's no index 3. That's why you probably are seeing undefined as a result. Thanks for trying it out. So you're trying to do this matrix of 2, which is giving you the second row, as you can see, of 3, which is giving you undefined, because in this third row, did I say second row? In the third row, there's no item on index 3, but there's an item on index 2, for example, and it's 9. Oh, okay, now I got it, thanks. Okay, and if you go 1, you see the 8, and if you say 0, you're seeing the 7. And then you move this one here, 0, 0 is the element 1. 1, 0 is the element 4, because you are going on row 1, second row, and first element of this row, which is 4. Okay, so you can mix arrays with other things. It doesn't mean you're supposed to do it, but if you're trying to add an empty array with 1, what happens is that everything will be converted into a string. It's not really surprising because, as I already told you, well, arrays are actually pretty similar to strings. And what happens here is that probably the array is automatically converted into a string, and in this case it's an empty string because it's an empty array. So empty string plus 1 means empty string plus the string 1, it will give you 1. If you have an array containing the number 1 plus 1, again, this array will be converted into a string 1, and so you've got 1, 1. And if you have an array with 1 and 2, you already saw here that if you try to convert the array into a string, it will give you comma separated values. So that's why you have 1, 2 concatenated with 1. Is this the way you would build machines in JavaScript, or is there a proper way to do it? Also, if you want to multiply matrices, you have to follow a certain scheme. Oh, sorry, I said machines, matrices. Yeah, actually, matrix calculations are pretty complex. And instead of just using matrices by yourselves, you can probably find a library that does all those computations for you. In fact, for example, if you have 2 matrices, there's not just one way to multiply one matrix by the other. There's also the tensor product, for example, that is used in quantum computing. And so probably you can look for matrix.js. And there is a page on the Mozilla Developer Network that tells you some of the things that you can do by yourselves. And there's also an interesting thing here. You don't need to represent matrices as arrays of arrays. In fact, if you want, you can just represent them as one-dimensional array you just need to perform some extra calculations in order to tell when you are on the second or the third row. But you can represent a matrix in a one-dimensional array. As you can see here, the array has one dimension, but with the new lines, it looks like a matrix. But it's not an array of arrays. It's actually, if you put this on Prettier, it probably shows you all the numbers in the same line or every single number on a new line. So yeah, but it's not what I was trying to look for. This is what I was looking for. Yeah, there is apparently a library called math.js, which allows you to perform the most common operations on matrices. So for example, if you represent an array, a matrix like this, you can create a math matrix given that array of arrays or given another array of arrays. And in that case, you can ask math, this object, this new object. It's not the usual math object. It's an object that is provided by the library. You can square the matrix if it's a basic array or if it's a matrix object. It's able to do the square of the matrix. You can add matrices together. You can multiply matrices or matrices. It's exactly the same together. You can create a matrix of ones with dimension 2 rows by 3 columns. And let's see what else you can do. You can create a subset. You can even use complex numbers. You can create vectors of zeros, vectors and matrices. You can create ranges. So many things. Is there a way to create a tensor product by chance? No, I don't see tensor product available. Yeah, but you can do things. You can multiply matrices, etc., etc. Okay, so and you can also calculate the determinant of a matrix, etc. Want to become famous? Buy followers, primes, and viewers on that stupid link that is now enabled again because I wanted to give you guys the ability to send me links or just to write some JavaScript without bothering this thing. So I'm going to ban this user as soon as they find a way, as soon as they see that I'm not blocking the links, they are sending links. Bots, let's call it spammer bots. Not spammer bits, spammer bots. Bam. Okay. Buys Vilpknv0403. So, as you can see, matrices are pretty tough to calculate. So, in programming in general, whenever there's someone who can do the work for you, make them do the work for you. Don't reinvent the wheel. Don't create your own library that performs the calculations on matrices. There are so many tools out there that you can use ready-made for you. And don't worry, later on we will see how to use those libraries in your code. We already started seeing them, but we'll do this in a little more detail. Okay, so yeah, you can sum arrays with numbers and it will give you strings. Because an array is converted into a string and this becomes a concatenation of strings. Blah, blah, blah. Don't compare arrays with the non-strict equals. Well, don't compare arrays, actually. Arrays behave like objects. So the same pass by reference, pass by value concept applies in this same situation too. If you have one object and you create another reference to the same object, these two references are the same, right? Instead, if you create a different object which has the same shape, well, obj2 is not equal to obj3 because they are references to two different objects even though they look equal. They are equal, they are not the same. And the same exact thing applies with arrays. So if I create an array 1, which is an empty array, and I create array 2, which is a reference to array 1, well, array 1 should be strictly equal to array 2 because they are references to the same object, to the same array. But if I create an array 3, which has the same shape, again, array 1 is not equal to array 3 this equality is false. So nothing new here. Arrays, just like any object, are subject to this thing about creating references to objects and arrays, not creating copies, just like with primitive types. So I think that's pretty normal to say that empty array is not equal to empty array, because these are two different arrays which have the same shape. And the same goes with array containing 0. But if you start comparing arrays with numbers or strings, something strange could happen. In fact, for example, 0 is non-strictly equal to an empty array because probably the array is converted into an empty string, and 0 is also converted into the empty string. Well, no, it's not converted into empty string. It's converted into a falsy value. This is falsy. The empty string is falsy, so this is true. This is not falsy because a string containing 0 is not an empty string. The empty string is falsy, but not a non-empty string. So this becomes false. But as always, never compare anything with double equals. Always compare everything with triple equals, which will take into account also the type of the elements that you are trying to compare. So with strict equality, an empty array is definitely not the number 0, because 0 is a number and the array is an array, and that's it. So that's the only stuff that I wanted to show you about arrays for now. Do the tasks, please. I'm going to do the tasks next Wednesday, of course. They are pretty interesting, and probably some of them can be even difficult. Array methods. We already know some of them, right? We already saw the push, pop, shift, and unshift. Is this too small, too big? Okay. But we also have other methods. Some of them I really recommend to use them. Some of them, not really. For example, there is a method here called Splice. And I hate this method because it looks like slice from strings. In fact, even arrays have the method called slice. So if you remember strings, a string like hello world is able to slice from an index to another index, and it will give you a substring of that string, right? Arrays have a similar thing. Let's go with numbers. 1, 2, 3, 4, 5, 6. And if I slice from 3 to 5, it will give me a sub-array containing only the elements from index 3 to index 5 excluded. Let's go to 3 to 6. Okay, so slice is a method that both strings and arrays share, which creates a sub-portion, a slice of the original element. And as you can see, just like with strings, slice doesn't change the original string. The original string is still there. If you don't believe me, let's call it str. Let's put it in a variable. Now I can ask slice to that string. And as you can see, the results are the same, but the string remains unaffected. And the same goes with the array. If I create an array which contains the number 1, 2, 3, 4, 5, 6, and I slice this array, you will see that array slice returns a new array containing only the elements in that subset, but the original array is unaffected. This is an immutable method because it's a method that doesn't change the object but just gives me a new result. And then we've got Splice. Splice has a similar name, but it has a different behavior, completely different behavior. So Splice seems very similar because it has this first argument, this first parameter in the function, which is the start index. But then the second is a count, is the number of elements you want to remove from the array. And then you also have other parameters, optional. Everything is optional here. In fact, you can see them in square brackets to denote the fact that the only mandatory parameter is the start index. But After the delete count, you can even put elements that will be pushed at the end of the array. Well, not at the end of the array, no. In that same place where I'm splicing, if I remember correctly. As you can see, I'm not a fan of Splice. I never use it, and so I don't even remember that much how it works. So if I've got an array like this one, okay? Let's do a splice. Starting from index 2, which will be the number 3, I'm going to remove 2 elements, so is going to remove number 3 and number 4. And in that position, it's going to add 2 elements, which I will put as strings, hello and world. And if I do this, the array splice is returning to me the elements that were removed, which are 3 and 4, and the array, the original array, changed. And as you can see, I removed the elements that I wanted to remove, but I also put elements inside. So it's probably a good way for replacing elements inside of the array, or just removing elements from within the array. So let's try again. Let r again is equal to, let's use letters because I don't want you guys to be confused with all these numbers. Let's do A, B, C, D, E, F, G. Okay. No, because array was already declared, so now it's going to work. Okay, I've got the array, and now I want to splice again. I'm going to splice removing, starting from 1. What happens if I just say 1 without the delete count? This is what happens. It returns all the subset of elements from index 1, and the array now is just the element A, because when you don't specify the delete count, it will delete everything from index 1 to the end. Let's redefine the array again. And this time I'm going to do splice from 1 and count of 3. So it's going from index 1 and it's going to remove 3 elements, B, C, and D. B, C, and D are the elements that are returned from the splice function, and the array is now changed. It doesn't have B, C, and D anymore in between. And once more, if I also add other things in here, like hello world, or just hello, as you can see, this returns the elements that were removed. And when I inspect the array, it has A, hello, E, F, G. This proves that you don't need to put exactly the same amount of elements that you were removing. You can add whatever you want. You can even not add anything at all. Okay, so Splice is very versatile because it allows you to remove things, add things in the middle. But one thing that I really hate about this is that the signature, the shape of this function is really similar to Slice, because Slice needs a couple of parameters optionally. Well, the second parameter is also optional, but if you want to put that parameter, that's the end index. And in here, this is not the end index. In Splice, it's not the end index, it's the number of elements you want to remove from the array. A little late, but good morning, everyone. Hi, Sao. No worries, no worries. We are looking at array methods. So we started looking at push, pop, shift, unshift, and now we are looking at this awful method that I hate. It's called splice, which is very similar to slice. So as you can see, these two methods are very similar. They can be confused pretty easily. I started confusing them a lot until I decided to never use splice. So I avoided the confusion altogether. And also I don't like methods that change my array. I prefer methods that are immutable, that do not change my initial object, but just give me a copy of that object changed somehow. So if I want to remove elements from this array, I would probably do something else, which is a little more complicated, I must admit, but I think it's better. If I want to remove, let's say, B, C, and D from this array, I would say that, well, probably I cannot even tell you. Let's find out. I need a substring from A to itself, plus a substring from E to G. So I want to split this array into two parts, one containing the A and one containing E, F, and G, excluding B, C, and D. So I can do something like array slice from 0 to 1, and this will give me the first subset. Starting from the index 0 to index 1 excluded, this is the array that I want. So this is the, let's say, the first part, the left part. And now for the right part, I can do array slice from, we can start from 1, 2, 3, 4 till the end. And this is let right. Now I have left, I have right, and I just need to concatenate them all into one single array, which will contain A and then EFG. But how do I concatenate these arrays together? It would be nice to be able to do something like left plus right, but it doesn't work. The plus in JavaScript doesn't allow you to concatenate arrays together. In fact, since the plus is only used to sum numbers or concatenate strings, the arrays will be converted into strings and then concatenated together, which is not exactly what you want. Another thing that you can do, and probably it is written here somewhere, I don't know, there's also another method called concat. So if I say left.concat right, this will concatenate the left array with the right array, giving you a new array, which is the concatenation of the two. And again, the array is left unaffected. Left is left unaffected. All these are untouched. I just created a new array, which is the result of concatenating the leftmost part and the rightmost part. But I can understand that Splice does all of this in one shot without even needing to create all these variables. And so if I want to do this kind of substringing, I have to do either array.splice starting from, starting from 1, remove 3 items. Did we say something like this? Let's see. Yeah, and this changed the array so it's A, E, F, G. With Splice, with one line of code, very simple, you have exactly what you wanted. If you don't want to use Splice, I'm going to do it again, you have to do something much more complicated in order to ensure this immutability. You have to do something like r.slice 01 .concat with r.slice, what did we say, 4? Yep. And this gives you exactly the same results, but it's returned and the array is left unaffected. So immutability has a cost, but we are going to lower this cost with some new syntax elements that are available nowadays in JavaScript, starting from ECMAScript 6, which make this immutable thing a little nicer to see. Let's see if they speak about this right now. Oh, negative indexes are also allowed, just like in Slice. And we already know about Slice, right? It's exactly the same as you have in strings. So I'm not going to tell, oh, concat, here it is. So if you want to concatenate arrays together, you use r.concat with another array. And you can even concat multiple arrays at once. This could be really useful if, for example, you want to start with an empty array. Let r is equal to the empty array. And then you want to concat multiple things together, like 1, 2, and also 3 and 4, etc., etc. So as you can see, this could lead you to create some of those algorithms in which you start with an empty array, and the more you go, your array will be filled with more and more elements. The empty array is the neutral element, like the 0 is the neutral element in a sum, the 1 is the neutral element in the product, and the empty string is the neutral element in a concatenation of strings. So now you know how to do all these concatenations of strings. Okay, now they're trying to mess up by concatenating arrays and things that are not even arrays. This is an object that tries to mimic an array because it has a key value pair, 0 something, and it also has a property called length of 1, but I think that this is just not going to work. And in fact, don't try to concatenate arrays with something that is not an array. Please, don't. Just don't. Okay, and finally, I can show you some really, really cool things that I really, really love about arrays. So I'm going to create a new folder here, which I was probably supposed to do a long time ago. Let's call it JS Arrays. And I'm going to create a new file called array methods. Okay, so as I already told you, there are multiple ways to iterate over an array, and all the methods that I showed you before, I just don't like them. Let's recap them. If I have an array like let r is equal to ABC, it's easy as 1, 2, 3. Now, if I want to iterate this array, I can do it either with the usual for with an index. So for let I is equal to 0, I is less than r.length, which is a property that we have in the array, and then I++, and now we can just console log r of I. Okay? This is feasible, and if it's feasible with a for loop, it's also feasible with a while loop and with a do while loop. You just convert this loop with whatever you prefer. But then we also have the for of loop, which is something like for let item of r, and now you already have a reference to the current item. You don't have a reference to the index of the array. And if I remember correctly, there's no way to get the index of the array from this for of loop. So if you need the index, you have to use this one here, because this way you can get the item, which is array of I, and you also have the index, which is I. Okay? Not really sure that I cannot use the index. In some languages you can do something like let item and I, but I don't think it's in this case. No, they say it's not feasible. So watch out. There are some languages, mainly template languages, that allow you to get the item and also the associated index with some kind of let of, but it's not this case. And when I'm talking about this, I'm talking about Angular. In the Angular framework, let me see what ng for of does in Angular. In Angular, in the framework by Google and Microsoft, you are writing HTML mixed with some special attributes that they provide to you, in which you can write some sort of pseudo JavaScript, like let item of items, index as I, track by function. So as I see now, no, there's no way to say items, comma I, but you have this index as I. But this is Angular specific syntax. This is not JavaScript. And this is one of the reasons I don't like Angular, because it forces you to learn a new syntax that is Angular specific and that you cannot spend anywhere else. Instead, other frameworks like React, or even no, I don't want to say Vue, because Vue suffer from the same problem. A framework like React just uses, let's say, plain JavaScript constructs. In Vue.js, let's see how you loop In Vue.js, you loop with item in item. So it looks like you're iterating with the for in loop, which is usually reserved to objects, which is even more confusing for me. I don't like this thing. I don't like to loop over arrays of items with a for in loop. And if I want the index, oh, here it is. As you can see, Vue.js uses the parentheses item index. This is Vue specific, Vue.js specific. So Vue.js and Angular, in my opinion, but you could have a completely different opinion, but these two frameworks force you to learn their own specific syntax when you want to iterate over items in order to present them in HTML. React instead does another thing, but I'm not going to show you immediately because I would like to show you how else you can loop over arrays. Everything's fine so far? Going too fast? Saying things that are too strange? I know that this reference to Angular and Vue could sound pretty strange for the newbies here that never saw a library, even worse with the frameworks. All good for me. Hi, Red Hottie. Awesome. Okay, so what is another way to loop over arrays? Well, arrays have lots of different methods, and we already started seeing some of them. For example, we saw pop, we saw push, we saw shift, slice, etc., etc. But as you can see, there are so many other methods that we can use. One of them is called for each. And this is a method that allows you to loop each element over each element of the array. The for each is a special method that doesn't accept numbers as parameters. It accepts a function. So you have to write a callback function inside of here, like this one. This is one of those methods that accepts functions as parameters, and that's why I insisted so much on showing you functions and how to use functions and functions expressions and anonymous functions and etc, etc, etc. This is really, really important. r.forEach accepts a function, a callback function. This function will be invoked automatically by the array itself for every element, for every item that is iterated over the array. Bobby, and you didn't teach us closure, which makes me suffer now. You know why I didn't teach you closure? Because closure is a subject that I was going to cover in lesson number 15, if I remember correctly. But you already know about closure. I already told you. You know what a closure is. Because you even know what an IIFE is, and you know why we started using IIFEs, because they provided closure. They allowed you to not make some variables available from outside. But anyway, we are going to look at them. Oh, sorry, Angela, I didn't see your message. Sorry, why did we need to have const item is equal to array of I? Or is it optional? It's completely optional. In fact, at first I said R of I, but now I said item because I wanted to show you how you can console log the item and the I and the index if you want to. But with the for of loop, you don't have a reference to the I. You can do strange things. So for example, you can say let I is equal to 0. And here you can print I, and then at the end of the loop you can say I++. But then, in that case, why even bother with the for of loop if you are going to create an index? Okay? So let's go back to the for each loop. For each loop requires a callback function. This can be an anonymous function, or it can be a named function. You can define the function anywhere else, and you can put it inside of here as a reference. The function accepts 3 parameters at most, one parameter at least. The first parameter is the current element being iterated. So you can just do console log of elem, and that's it. This has exactly the same behavior of the for of loop that we saw so far. But this function also accepts the index. So if you want, you can also print the index. And there's optionally a third parameter, which is the array itself. Not really useful sometimes because you already have the array here. So if you want to print the array, you can print the array even without this parameter. You have the array from the outer scope of this function. But sometimes you prefer to always have functions that depend only on their parameters, right? You only want, we call them pure functions usually, when they depend only on the inputs and they only give one output. This is not a pure function because it's not giving you any output, and it has a side effect of printing things. Pure functions usually don't have any side effects. So this is not a pure function, but it's a function that only relies on the input and not on other variables that come from outside of this function. Okay, so this is another cool way to iterate over an array. You can use the for each loop. And let's see how it works. I'll try it here. Let array is ABC, but I think I have to refresh the browser. And if I do this, array.forEach, callback function on the current element, the current index, the current array, I'm going to console log all three. There we are. Now we see every console log has the current element, the current index, and the current array, which is always the same. So usually this third parameter is not really used. We don't care about it. In fact, we usually do something like this, just print the elements. And that's it. So this is exactly the for of loop. But it's done with a method from the arrays, which is called forEach. If we want to print all of them, we can do strange stuff, and this is probably going to be quite difficult to grasp. I don't know if I want to tell you right now. Probably not. No, I'm not going to tell you right now. Let's go with the simple stuff right now. So forEach allows you to loop over things. But there are some special cases in which I want to loop over an array to do something very specific. For example, let's say that I have an array of numbers. So const r is equal to 1, 2, 3, 4, 5. And it's going to complain because I already defined the array, blah, blah, blah. But I don't really care. I've got an array with 5 elements. Now I want a new array that has all the elements squared. How do I do that? Well, I can do it in multiple ways, of course, and let's just use the forEach for now. r.forEach function containing the element, and I have to do something like creating a new array and pushing things into the array. This array will contain all the squares of the initial array. As you can understand, I'm trying to create a new array that does not mutate the original one. It is a new array with the same number of elements of the first one, but with all the elements squared. So I can do something like this. I can start with an empty array, let squares is equal to the empty array. Okay. Then for each element in the array, I can push inside of the squares array that at first is empty and then it gets incremented along the way with the element squared. How do you square an element? You can say element asterisk asterisk 2, or you can say element times element. It's exactly the same thing. And that's it. At the end of this loop, I should have the squares being an array that contains all the elements of the previous array, but squared. Does this make sense? Let's try it out. So to recap, I have an array with 5 elements, 1, 2, 3, 4, 5. I want a new array which contains all 5 elements but squared. and I want to not mutate the original array. I want the original array to stay there. Okay, so I'm going to start with an empty array, and for each element of the original array, I'm going to push a new element inside of this array, which is the result of squaring that number. And at the end, I will have an array of squares which contains this: 1, 4, 9, 16, 25. The original array is left untouched. This is one of the easiest algorithms out there, and you can probably make it even simpler by using another method of the arrays, which I love, and it's very, very used, especially in React, and it's called map. You can say r.map. Map is a method in the arrays which has exactly the same parameters of for each. So it's a function that has the current element. You know what? I would call it item. I prefer to call it item. It's exactly the same, but I probably prefer to call it item. Oh, are elem index array keywords that are automatically recognized as attributes of the array? Are they specific to for each? Okay, I was probably answering right now to this question. Do I have to call it elem or item? As always, no, because in a function, it's the order is important, not the name of the parameters. If you look at the for each documentation in JavaScript, you will see that for each requires a function, a callback function, and the callback function will have, there's also a for argument optional, which I didn't know. It's the this. Okay, so the parameters that we have in this callback function can be called, for example, current value, index, array, this argument. The most important part is the position. So if you want the element, the current element, this must be in position 1. If you only need the index, you cannot just remove element from here, because index is now in the first position, and even if you called it index, it's actually the current element. So it's very, very important to place things in the correct position. If you don't need the element because maybe you don't want to print it, you just declare it and not use it. But there must be something in this first position in order to be able to access the second parameter, the index. If you don't like elem, you can use the underscore to say, I don't care about this value. Or in other situations, in other languages probably, I even saw that you can just put a comma, an empty comma, but it doesn't work in JavaScript. As you can see, ESLint complains about this. So you can use an underscore or just item or elem or any name you want. The important part is the position of this parameter. So array for each requires an item, and then optionally the index, and optionally the array, and apparently optionally there's also the this argument if for any reason you need the this argument. But usually we just have function of item or function of item and index. This is what I saw most of the times. So Arraymap function item map looks very similar to for each. But for each doesn't return anything. This callback function doesn't return anything, and the for each doesn't return anything. All of this is undefined, and the array of squares is incremented as a side effect of calling this callback function multiple times. And at the end, you have the squares. Map does another cool thing, which is very nice. Map, as the name says, maps every element in the input array with an element in the output array. So map actually returns something, and it returns a new array which contains exactly the same number of items of the original array, but these items are being changed with this callback function that is invoked on every single item in the array. So for example, for every item here, I can return the item squared. And when I write a thing like this, this has exactly the same behavior of this other code here. It automatically creates a new array, and for every item in the original array, it will push the changed item in that array, in that new array of squares, and the result can be even stored in a variable called const squares. So as you can see, map allows you to do exactly the same thing that we've done here, but with fewer lines of code. We can even make it shorter, and now I'll show you how. But let's see if it works. So I've got my array. I have to write my array here. Okay, this is my array. And now, if I want the squares, I can invoke r.map with a callback function that, given the current item, returns the results of transforming that item in some way. In this case, we use the square of the item. And this gave me a squares, if I write it correctly, a squares array which contains exactly the items squared. And still, the array isn't mutated. The original array is left unaffected. Okay? So why do I really like this thing? Well, because as you know, I'm a fan of arrow functions. So if you want, you can transform this callback function into an arrow function. And if I transform this into an arrow function, it's as easy as removing the function keyword here and replacing it with a fat arrow on the right. That's it. But now that we've got an arrow function, we also know that when the arrow function does just one thing, and that one thing is returning the result of an expression, well, we can remove the curly braces and the return statement, and what we are left with is this. Look how nice and clean this function is compared to the for each as written like this, or compared to the for of loop. It's so nice looking. And it could be even more nice looking if we decide to take this anonymous arrow function and instead give it a name. But this is actually pretty hard to understand. I hope that it's not that hard, since we already done a couple of these function swapping exercises together. But let's try. This is an anonymous function. I can give it a name. So I can just take this anonymous function, save it somewhere. For example, I'll save it here, and I will give it a name like square. This is an arrow function that is called square. If you don't like this way of writing it, just remember that this is actually equivalent to say function square is a function that, given an item, will return item times item. It's exactly the same thing. But as you know, a function declaration can also be written as a function expression, which is something like const square. Oh, come on, dyslexing today. Const square is equal to an anonymous function like this. And as you know, an anonymous function like this one can be easily translated into a arrow function, which we already did. Okay, so I hope that this square with arrow function makes sense to you. And now that we have a function that does exactly the same thing of this anonymous function, I can replace this anonymous function with just a reference to that square function. No parentheses here. Remember, I don't want to invoke the function right away. I want to pass a reference of this function to the Arraymap method, so the Arraymap method will be able to invoke this function as soon as it finds suitable. Okay? Very similar to the event handlers situation that we saw some lessons ago. So you can do this kind of swapping. You can have an anonymous function directly written in here, Or it can be not an anonymous function anymore. It can have a name like square, and you just pass that name, you pass a reference to that function in the array.map, which makes it even more readable if you want to, because now you have a function called square that given, it shouldn't even be called an item, it can be called a number. Square, given a number, is giving you number times number. And then the array of square is just the result of, hey, array, map every one of your items with this function that does the square of the number. And you can do this with any other function now. For example, I can define a new function called, I don't know, let's say increment by 2. And this is a function that, given a number, will give me number plus equal 2. 2 with a, of course, with a W, but the W sometimes fails me on this keyboard. I'm sorry for that. And now, if you want a new array with incremented numbers, you can just say r.map increment by 2. And this will give you a new array with all the original items incremented by 2. Actually, this can be even written as number plus 2. Just give me the number plus 2. I don't need to change the original value. Just give me whatever is the result of adding 2 to the number. Shall we try those two functions? Let's see what happens. The original array is already there. And go. Nope, because squares was already declared. Thanks a lot. Thanks, Obama. Poor Obama. Do I have the array? Yeah, I got it here. So I'm gonna copy this array of items, and now I'm going to use these. So as you can see, I'm defining two generic functions that can be applied anywhere, not only on this array. I'm just defining a function that does a square of a number, and I'm just defining another function that increments a number by 2. And then I can use those functions as callback functions in the array.map method of the arrays. And now squares contains the squares, and incremented numbers has the previous numbers incremented by 2. Hope it makes some sense, but you will see that with practice it will make much more sense. You also have to know that this practice of placing a reference to a function as callback is actually an advanced concept that I saw many JavaScript developers are unaware of, but they are missing so much. It's so good to have this this fact of being able to place references to functions into other functions. This is what makes functions first-class citizens in JavaScript, and this is what makes JavaScript a highly functional language. It has the functional paradigm engraved in the language, which I really love. Okay, so we've got the for each, which is able to loop, and we've got the map, which is also able to loop, but it's also able to do a very specific thing. It loops and it returns a new item in the new array for every single item in the original array. That's why it's called map, because the array that you have will always have exactly the same number of items, but those items are transformed with some sort of mapping function. And this mapping function can be called square or increment by 2 or whatever you like. And then we've got other methods. I don't know if those methods are all listed here. Maybe not. Yeah, they are. Yeah, most of them. Okay, let's go in their order maybe. I said for each, and I didn't tell you about index of or last index of, but I think that this is pretty, and also includes. But I think that these are pretty straightforward because we already saw them in strings. And in fact, the string is some sort of a special array if you think about it. It's an array of characters. And so just like in a string, you can check what is the position of some substring or the last position of that substring, or you can check if the string contains a substring. Well, with arrays you can do something similar. It's not exactly the same, because in strings you can look for substrings, which are themselves collections of characters. In an array you can just look for one item at a time. So for example, array index of one item, given optionally the index from where you want to search, we'll look for that item, and we can see it here. Array index of 0 will give me 1 in this case, because if the array contains 1, 0 and false, where is the 0 here? Not in position 0, it is in position 1, and that's what's returned from here. What is the index of false? Well, false is in position 0, 1, 2, so it will give me 2. And what is index of null? Well, there's no null in this array, so it will give me -1, a special number that tells me that the item was not found in the array. And it's a special number because -1 is not a valid index in any array. Indexes are either 0, 1, 2, or any number up to infinity, but never a negative number. So -1 will always tell you, I didn't find the index. I didn't find the item. There's also an array.includes1, which just gives you true or false if the element was found. It doesn't give you the index where it was found. It just tells you if the element is there or not. Okay? And yes, the element is there. It's at position 0. Okay, we've got special cases for none, but I don't care about that. Now, if you want to find an item inside of the array, there's an array.find method. So I can use r.find, which behaves very similarly to for each and map. In fact, even this one accepts a callback function, which contains the item, the index, and optionally also the current array and also this argument, but we don't really care about those. We usually care about the item only, okay? And when I write these callback functions, I usually prefer to write them as arrow functions because they look cuter. So I'm going to write it like this. Array.find item. This function behaves slightly different from the others in the sense that find is just going to give you the item that it found if it found it. Otherwise, it's going to give you, I think, undefined. So the function that I have to write here is actually, we call it a predicate, which means just a function that returns a Boolean. A predicate is a function that tells you either true or false, given some condition. For example, I can say item should be even, and I want to return this thing. This is a function, a method of the array that will find the first item that is even in the array. And it will be returned const even number is equal to whatever is returned from this function. Shall we try it? I went a little fast on this, so I want to slow it down. Okay, array.find is a method that accepts a predicate, and a predicate is just a function that returns true or false. And in this case, if the predicate is not clear enough, I can give it a name. I can call it like this, isEven. IsEven is a function that does exactly this. I'm going to do exactly the same trick as before. I'm going to cut this arrow function, which is anonymous, and I'm going to give it a name here, and I'm going to replace it as a reference to that function. This actually behaves exactly the same. But now the arrow function, as you can see, well, it could be also changed before, but now I want to change it as just a one-liner because we are just returning one thing. It's a Boolean value that is telling me if the item is even or not. So have a look at this, how easy it is to understand that this function is finding in the array any element that is even. Look how readable it's becoming. Let's try this new function. So I'm going to declare isEven here. And now I'm going to check array.find isEven. It says 2. Why 2? Because if I look at the original array, the first number that is even is actually 2. So it found the first item. What about the index? What if I want the index of the first even number? Well, there is a function called array.findIndex. And given the same function, we can reuse that function multiple times now. It gives me 1. Why 1? Because 1 is the index of 2. 2, the number 2 here, is in position 1. 0, 1. So that's why it's giving me 1. Okay? So now that we understand how to create those very easy callback function, it's actually pretty easy to mix and match them. This is the even number index, and it's array.findIndex is even. You reuse the same function as the predicate that will tell you what is the condition to for which to find the element or the index in the array. And of course, you can do all these things with the usual loops. If you want to find an element in the array that is even, how do you do that? I'm going to write it really quickly and then remove it, because you already know how to do that. You do something like let even number is equal to undefined. Then you loop over all the items in the array, and if you want, you can use the for of loop. So let item of array, and you say if the item is even, so you can say item %2 is equal to 0, or you can reuse that function there, is even given the item. I already wrote that function, so why not reuse it? It actually has exactly the same meaning. If it is even, then even number is equal to that item. Otherwise, and then I want to probably break the loop. I want to stop there. And if I'm in a function, I can just return that even number. But I have to somehow break the loop here. And with the for of, there's no way I can break the loop without using break or return. While we already saw that when we are doing this kind of loops here, we can always break the loop by changing this continuing condition, right? So yeah, we can do all of this and it works, but we can also write it like this, and it's just a one-liner, and it's even more clear probably. Well, at least as soon as you get the hang of it. Even number is array.find is even. Find in the array the first number that is even. It speaks English. This is not really speaking English. It's speaking very convoluted, right? So all these methods, array methods, are actually optional because you know multiple ways of looping arrays, but these make looping so convenient, and they preserve immutability, which means that the array is always left unaffected. You're never mutating the array in the first place, which is usually something that we look forward to. Okay, some other methods. Filter. Let's say that you don't want just the first item that is even. Let's say that you want the subarray of elements that only contains even numbers. So in this case, it would be 2 and 4. I just want to filter out 2 and 4. How do I do this? Array.filter, given the same function, is even. There it is. How do I do this in usual coding? You say something like const filtered array is equal to an empty string, and then you loop over all the items in the array, and then if the item is even, I can reuse that function, then I'm going to push to push that item in the filtered array, and then finally the filtered array will contain all the elements that are even, excluding all the odd elements. But now I can do something like this. Const even numbers, not event, const even numbers is array.filter is even. And that's it. Just one line. And as you can see, I'm reusing is even so many times. And I can also use something else. I don't know, I can create another predicate. So if it's not even, it's maybe a prime number. And I can filter out from the array all the numbers that are prime, all the numbers that are odd, all the numbers that, I don't know, I like. So as you can see, once you know one of these methods, you know them all. You just see that there's a difference. Map creates a new array which has exactly the same number of results of the original array, but with every item changed. Filter gives you a new array, which is usually smaller because it contains just a subset of the elements of the original array, just those items that match some condition, some predicate. Find will just give you the first of these items. Find index will just give you the index of such an item. Map, I already showed it to you. Sort, I don't think it's actually one of that same kind. Sort is actually a completely different thing. I wouldn't have put it there, but I'm going to tell you. Oops. So what is sort? If I have an array with all the elements unsorted, let's start with strings for now. So I'll say, I'll put your names, guys. So in order of appearance, Tiago, I should say Tiago MXX. This is your actual nickname. Kaisa219. And then there was, let's also put the spammer there. Svilpknv 0403. I hope you're not offended, bot, by my attempt at writing and pronouncing your name. Then we've got Sao Ferreira. I hope I wrote it correctly. And then we've got Red Hottie. Who else is there? We've got Bobby in order of appearance, which is Jabata. Okay, this is our array. This is our array. If we want to sort this array alphabetically, you probably started looking on the internet at a certain point and found out that there are many sort algorithms out there. In fact, there's a whole Wikipedia page about how to sort elements in an array in the most performant way. There's algorithms called quicksort, merge sort, in-place merge sort, intro sort, heap sort, insertion sort, block sort, etc. So many. And also non-comparison sorts like this one, pigeonhole sort, etc. Bead sort, bogo sort, etc. There are so many, and this is one of the most hard problems that we deal with in software programming and software engineering. I think that Tiago shared a meme about this recently, right? Was it Tiago? Let me check. No, apparently not. Oh, wait a second. Yeah, here it is. Sorry. Can you guys please recommend books that made you cry? Data Structures and Algorithms in Java, 2nd edition. So what does this book talks about? And I had to read it. I had to study. I had to do exams about this. Data structures are arrays or other data structures such as trees or, also objects, also called maps, sets. There are many data structures. And we don't really care too much about those data structures in JavaScript because in JavaScript you already have objects which behave like map, hash tables, dictionaries, structs or whatever they are called in other languages. We just have objects. And arrays also behave like queues, stacks, vectors, linked lists, array lists, etc., etc. So we just have these two data structures. The only thing missing here is trees. Sometimes we also need a data structure called tree, which is, well, you already know what a tree is. It's usually a node that is a parent of some children. And those children can in turn be parents and have multiple children. And in that case too, you can create algorithms that look for a specific item in this kind of structure. So that's what makes this book kind of difficult and makes you cry, because there are many data structures to study and there are many algorithms that sometimes can feel quite complicated to grasp or quite complicated to write, to implement yourselves. In JavaScript, it's actually the same. If you want to implement the quick sort, you have to write the quick sort by yourself. Or there's this r.sort function that just applies the best sorting algorithm that JavaScript decided to use in your case. So you don't need to implement any sorting algorithms. There's already a sorting algorithm there for you. And as you can see, the returned result is different from the original array. And one thing that I really hate about this sort algorithm is that it changed the original array. I usually prefer to have a new array, which is the sorted array, but leaving the original array unaffected. But that's what we have so far. And as you can see, the elements are sorted almost alphabetically. As you can see, Red Hottie, which starts with R, comes before Jabata, which starts with J. Why is that? Because if you remember, this is not pure alphabetical order. This is in fact ASCII table order, and capital letters in the character map on computers come before lowercase letters because they are associated with a numeric index which is lower than lowercase letter. That's why Red Hottie comes before everybody else. But for the rest, yes, Jabata comes before Kaiser, which comes before Sao, comes before Zvilpknvuk or 0403, which comes before Tiago MXX. Okay? And what about numbers? What if I have an array like this one? Let R is equal to, let's do 5, blah, blah, blah. I don't know, I'm messing around, okay? I've got these numbers, which are not in order. And if I try to sort these numbers, I probably will have a surprise. Everything seems cool, apart from 87. 87 should be the last one. So why is it before 9? Because sort is alphabetical by default. It's not numerical. So you remember what happens when you try to sort strings that start with 8. Every string that starts with an 8 will come before any string that starts with a 9. That's why 87 comes before the 9. If I want to make this sort numeric, I can provide a function. Sort allows me to create a function as a callback here. And this function behaves like this. It's a function that requires two parameters, item A and item B, let's say. This function will be applied to every item that should be compared one to each other. So it will be compared, it will probably compare 5 with 2 and will determine if 5 is less, greater, or equal to 2. And how do I do that? This cannot be a predicate. This cannot be just a Boolean function that tells me true or false. Because we have three cases. We've got either 5 is less than 2, we've got 5 is greater than 2, or we got 5 is equal to 2. Or let's just say with A and B. So this cannot be just a function that gives you either true or false. It must give me three values: less than, greater than, equal to. Angelo, but shouldn't then 2 come after 3 since alphabetical 2 comes after 3? It doesn't. No, 2 comes before 3. Character map. Okay, if you see this character map, you've got all the numbers in numerical order. So 0, 1. It doesn't compare the names of the numbers. Oh, no, wait. no, it's not the name of the... No, there's no way that JavaScript will take the number 2 and turn it into the string 2. That's not what's happening. The 2 is just converted into the string 2, like this. And that's why 2 is less than 3, but 22 is also less than 3. Yes, of course, it's less than 3 because they are transformed into numbers, but alphabetically speaking, 22, no, it comes before. Wait a second. Oh my god, it's always so difficult to come up with that result. Let's go with 87. Well, 87 is also alphabetically... Yeah, 87 is less... Okay, yeah, now I got less confused. 22 is less than 3, alphabetically speaking, even though the number 22 is not less than 3, numerically speaking. That's what I was trying to come up with. It doesn't compare the names of the number. It just, as Bobby says, it just turns those numbers into strings and treats them as indexes on a dictionary. In a dictionary, if the dictionary has the number 22 and the number 3, you will see the number 22 come before the number 3. Because it starts with 2, which comes before the number 3. And then we've got all the uppercase letters, and only after we've got the lowercase letters in the character map. And that's why we saw that Red Hottie came before everybody else. Hope this makes sense. So, if I want to sort the array numerically, let's do it here. Let r is equal to, I'm going to copy it. If I do array sort, dyslexic today, I will see that this is not giving me the result that I expected. I'm messing up, sorry guys. Today I'm pretty confused. I'm sorry for the poor service. Okay, so we were there with initial array, and then after sorting, we have this kind of sort, which is weird because it looks alphabetical. 87 comes before 9. If we want to make this sort, use another rule, for example, a numerical rule, then I can provide a compare function, a and b, given a and b, that will compare a and b and will give results according to the 3 different scenarios. A is less than b, a is less than b, I will return a value. A is greater than b, I'll return another value. A is equal to b, I'll return another value. What is this value? It's just a number, 1, -1, or 0. This is the only thing that I need. So I can write something like, if a is less than b, I will return -1, because -1 has this special meaning in this compare function, which says a is less than b, numerically. If a is greater than b, I'm going to return 1, because 1 means that a is greater than b in this compare function. Otherwise, I'm just returning 0. I know that I told you that usually we should put curly braces, but sometimes for this kind of functions, I prefer to keep them as small as possible. So yeah, you could put curly braces, but I think that in this case, it would make the code a little messier and more difficult to read. Also, as you know, I prefer using arrow functions. So voila, I turned my compare function into an arrow function for no reason at all, just because it looks nicer. So let's try to sort this array again, but this time using this compare function. I'm going to copy the array back here, and I'm going to sort using this compare function. Okay, now the numbers are sorted in numerical order because I'm using the less than or greater than. As you can imagine, this compare function is really powerful because now you can compare anything. You can compare dates and check if the, I don't know, if the year was less than the year of the other dates. We haven't spoke about dates, actually. We need to speak about dates. Or you can compare with any rule that you want. You can even turn the rules upside down. For example, if I flip 1 and minus 1, this is going to sort, but in descending order, probably. Yep, now they are in descending order. So you define the rule that you want to apply. It's up to you to decide how to compare one number with the other, and the sort function will deal with the sorting itself. So you can just throw away your book about data structures and algorithms. Not really. You should read that, and maybe there are some interviewers which will ask you about some data structures and algorithms. And I hate those kind of interviews. I had a few failures in my life, and some of these failures were being rejected by huge companies such as Facebook, or was there anybody else there? Yeah, there was another one, but I don't remember. Well, actually, Facebook is one of those examples. I was contacted by Facebook to have an interview, and the interview went really well until I got to the technical part. And in the technical part, they asked me some algorithms with trees and arrays and performance and computational matters, which are things that a young programmer, freshly, how do you say that? A freshman which just came out of university knows by heart. But I did university something like, I don't know, 15 years ago or even more. So it was really, really difficult for me to remember all this stuff. Apart from Facebook, there was another one. It was an Italian branch of the government, let's say. Then I worked for the government for a while, but I was not involved as an employee of the government. So in both occasions, I was asked to do these kinds of puzzles that involved searching and sorting and finding the best solution in a short time while the interviewer is watching you like this. It happened to me also one time in London, and that time I completely nailed the interview. I came up with the best solution in a short time, and I think that was pure luck. In that moment, I don't know why, I came up with the solution. With Facebook, maybe the pressure was too high and I didn't come up with the proper solution from the start. And I hate this kind of questions. If you try to go to Microsoft, Google, or Facebook, they are aware of this problem. And they are aware of the fact that they will probably get some, let's call them false negatives. So people that are worth being hired at those companies, but because of this very difficult exam, they will not be hired, and Facebook will lose the chance to hire good people. But still, they have to raise the bar really high. But I'm talking about Facebook, Microsoft, and Google. If you're not aiming for working for Facebook, Microsoft, Google, maybe the interviews will not be that difficult, and you don't really need to know this stuff. Also, if they know that you came from university, then yes, you're supposed to know this stuff. But if you didn't come from university and you just did an online course like this one, maybe I don't know if you're really supposed to know these things, and they shouldn't be supposed to ask you about complex algorithms, especially if you present yourself as a junior that just never did anything, but just has to do some experience. Bobby, yeah, unless you like competitive programming as your hobby, I guess you'll never work for the FANG. Yeah, exactly. Just a side note, Facebook was trying to hire me for a position that I actually didn't even like. So I'm really happy nowadays to have being rejected the first time, and then the second time that they contacted me because they thought that I was still an interesting element, and they wanted to interview me once again after 1 year. But the year after, I rejected the interview. I didn't want to be interviewed anymore because I don't believe in this kind of interviews, and I don't care about having this kind of interviews for a position that I didn't even like in Facebook. Yes, it's Facebook, but if you're drinking coffee in Facebook every day, well, there's nothing to be proud of, I think. Unless you're really into coffee, then in that case you should be proud of that. But if your passion is coding and they hire you for a position that is not exactly suitable to your aspirations, then I don't care if it's Facebook or if it's Microsoft or if it's Google or Amazon. I prefer do my own thing without even being interviewed. So I'm not, I don't want to, man, I really wish all people were thinking like you. There's so many people that are thinking like me. I'm pretty sure about that. But you will find lots of information about this on Google. Facebook hiring process, or Google hiring process, or Microsoft hiring process, how we hire. And they tell you things. I don't know if they tell you exactly the same thing, but you can find people also complaining about how those companies hire you. I remember it was really, really painful. In order to be interviewed by Facebook, I remember that I had to take a couple of days off my current job to recreate, study and re-implement all the algorithms and all the data structures that I studied 15 years ago in Java and translate them in JavaScript, because I knew that I would have been interviewed in the JavaScript language. And it was so painful and I had to rush it. And at the end, because of multiple reasons, the interview didn't go exactly well. I found the solution. I said the right solution speaking. But then when I started writing that solution, I started writing another solution because I was not sure I was doing the right thing. The interviewer on the other side of the phone was completely mute and I didn't understand what was their reaction. And I probably panicked in that moment. And so I tried to say, okay, maybe that's another solution. Maybe the solution that I came up with at first was not the good one. So let's try this other one. Oh no, this is not the optimal solution. It works, but it's suboptimal. So my first solution, the one that I said out loud, was the good one. And that's why I was rejected, because I didn't implement the solution, the optimal solution that I said out loud as the first solution. Okay, if you like it like this, yeah, there will be better people. I don't care. I really, really don't care. I'm really, really happy nowadays to have failed that interview. Okay, so this is the sorting function, but we've got so many other methods there. I know it's 12 o'clock, so usually we have the coffee break. But if you like, we can do another half an hour and then have a longer coffee break, maybe a lunch break, which can last 15 minutes, 30 minutes, you say. You tell me. So we can split this longer lesson into 2 equal pieces. If it's fine for you. If you object to this, please tell me in the chat. So, array methods. We saw the sorts. And let's look at... Ooh, look at that. Arrow functions for the best. If you want to create a sort comparator, which is very, very short, you can even type it like this. A minus B. Because A minus B will give you a positive result if A is greater than B. Wait a second, I'll try. Let's do this as A minus B. I'm really bad at maths. Another reason why Facebook shouldn't hire me. Okay, let's try with array sort. Oops. Okay, this is the array, and then I'm going to sort with this function here. Okay, it's exactly the same thing. Why? Because a minus b will be negative if a is less than b, and will be positive if a is greater than b, and will be equal to 0 if a and b are equal. So you don't really need to return -1 or 1. You just need to return any negative or positive number, or 0. And that's why this arrow function is so small, so concise, and so nice. 30 minutes more and 15 breaks sounds fine. Okay, so I'll go until 12:30 my time and then 50 minutes of coffee lunch break. What else? Okay, if you want to do a locale compare, I'm not going to spend any time on this. I don't care. You can compare strings not as character maps, but as locale. So according to your to your language. So for example, if you compare them the usual way, you will see that Österreich, I don't know how you pronounce it, Österreich. Well, this comes after Vietnam, because in the character map, any character with diacritic accents, or what they're called, are placed after the usual characters. But if you do locale compare, then in that case, the O will become before the V and after the A. Then we've got also array reverse, another method that I really don't like because it changes the array in place. But sometimes it's useful. You reverse the array and now you have the array completely flipped out. But the array is changed. And then this is one thing that I sometimes use. Instead of trying to create to do an array to string, which gives you this, you can instead join the elements of the array, and if you don't put a parameter, they are joined just like with the toString. But if you add a string as a separator, you will see the items being separated with a string that you specified. So for example, if you want them joined into a string but separated by a space, here is how you do it. If you want to be a comma but also a space, you say comma space, and they are joined pretty nicely. Or I don't know, you can put an asterisk, you can put a pipe symbol, whatever you want. Okay, so join is pretty easy to use, and you can turn every array into a string with all the elements joined as you like. And once you have a string, you can split the string given a splitter. For example, the pipe, isn't it going to work? Yeah. So I joined the array and I split it back again. Not really useful, but sometimes it is useful. So you have a string which is hello world, and you want to split the two words, you can do string split given the space. And this will give you an array hello and world. Or you can split with anything. If you split the string by O, you will see hell space W RLD exclamation mark. You can split however you want. I use split a lot, especially when I want to parse the query parameters in the address bar. Sometimes you see addresses that have multiple slashes, like this one, slash presentation, slash d, slash this number here, slash edit, and then you've got also the hashtag slide is equal to ID P6. Well, what is this address? Let's address this problem. Let address is equal to this. Okay, I know that this address has one part which is actually the address and another part which is called usually a fragment. It's whatever is after the hashtag. So one thing that I can do is create tokens, an array of the tokens that will be the result of splitting this address. And I can split this address by using the hash as separator. Now the tokens are an array which contains this part of the address and that other part of the address, which is the, we can call it the fragment, okay? But then, what is the value of the slide? Slide equals to id.p6. So if I want to say that I'm on slide number 6, I have to do some more. I have to say tokens is equal to, hey, you know the tokens? Take the second element, the element in position 1, this one here, and let's split it by the equal symbol so we can tell apart that other piece. Now tokens contain slide and id.p6. And now to get the 6, I can probably either split again with a dot, or I can just, I don't know, if I know for sure that this thing starts with id.p, maybe I can say just, I don't know, let's find the index of the 6, like tokens of 1 is the id.p6. I can check for, I don't know, index, let's say, I don't know, how can I do this in a clean way? id.p6, and I just want the 6. If I know, okay, there's another method in strings which is called replace, and in this method I can replace whatever is id.p with nothing, with the empty string. And now we've got the 6. I don't know if I showed you replace as a method from strings, probably not, but it's one of those methods that you just come up, you just learn them by heart, or you just try to look for them on the internet. So how to remove a substring in JavaScript. Yeah, as always, the W is not working. Oh, there's a replace function. How does it work? Visit Microsoft says the string, but if I replace Microsoft with W3 schools, then in that case, it says visit W3 schools. Okay, so just half a minute of searching and I find the replace method to do exactly what I wanted. Or sometimes you can come up with very creative solutions by yourselves. Sometimes I saw very strange things. For example, I saw people doing something like, you know the tokens 1, you split it into empty strings so it becomes an array, then you reverse the array, and this becomes an array containing 6p.di. Then you join the array back again, and you have this thing here, and then you just need to do a parse int of this value to get the 6. But this is completely nuts. I would never do this. But yeah, you can do things like that. As you can see, this looks a bit like method chaining, but it's not exactly method chaining because tokens 1 is a string. When you split it, it's an array, so I changed the return. I'm not reusing the same element to which I'm asking things over and over. And then I reverse the array and I turn it back into a string. Very strange stuff. I would never do this kind of thing. First, because it doesn't work in any case. For example, if I have a string called id.p16 and I try to do exactly this thing here, this will not work because it will give you a different result. If I apply this chain of things and maybe at the end I also parse int, what I come up with is 61 because I reverse the whole string, including the 16, which now becomes 61. So this is not working with 2 digits. As you can see, whenever you try to do something really, really smart and really, really clever, you're probably introducing bugs. Let's do things in a clear, concise maybe, but also a clear way, a predictable way. I would probably use the replace because replace will always work. If I do just replace that part that I know in advance, if I know it in advance, this is exactly 16, and it works for 1, it works for 6, it works for 16, it works for 61. Okay, so we can split an array, we can split a string into an array, and we can join the array into a string back again. Ooh, I've got some Lord of the Rings here. String also has split, which allows you to split the string. No, what I'm saying. Yeah, of course, string has split, which is exactly what we saw so far, which creates an array of all the single characters if the separator is an empty string. Just like I did right now. Join and split will split every single character and will join every single character. And if you want, you can join with a semicolon, and you will see Bilbo, semicolon, Gandalf, semicolon, Nazgul. And as you can see, the semicolon is never at the end. It's just the separator in between the characters, which is usually what we want, because if I have an array of fruits, apples, oranges, oh, come on, and bananas, well, you want to say something like, I like fruits.join, comma, space, and it says I like apples or oranges. I got it wrong. I tried multiple times to write it right. I'm sorry for that. I like apples, oranges, and bananas, and this is actually pretty, it's pretty standard English. This is the Oxford commas, right? You have to put the comma also on the last element. I like apples, oranges, and bananas, but with a comma. In Italian, we don't use this Oxford comma. We usually don't put that. And then the last, probably the last, the last method that I want to show you about arrays, which is similar to map, find index, filter, is actually pretty different. So I hope that it will not confuse you too much. The method is called reduce. And it's a bit strange, but it's very, very powerful. And it's so powerful that there are some libraries out there called, for example, Redux, which are all based on this principle of reducing. Redux comes from reduce, reducer, reduce. So what does reduce do? Again, this accepts a callback function, and the callback function doesn't have exactly the same shape as the callback function that we saw so far concerning maps, find index, and filter. In fact, the function right now has an item, the current item, it has the index, it has the original array if you want to, but the first parameter is another thing that I usually called ACK, an accumulator. Let's remember how to do the sum of numbers, okay? So what if I want to sum all the numbers that I find in an array? I would do something like this. Let sum is equal to 0. And then for every item that I find inside of the array, I'm going to increase the sum with that item. Or if I want to be more explicit, the sum is now itself plus the item. And then at the end, I am able to have the sum. Okay? Well, reduce is a way to write all these things inside of one function. The accumulator is this sum. It's whatever you want to start with an initial value, and then it gets incremented somehow, and it will be returned afterwards as the final result of the computation. So reduce will give me a result which is the final sum. And it uses an accumulator, which must be initialized, however. And that's why this reduce function doesn't accept only one parameter, it accepts two parameters. Because the first parameter is the callback function, and the second parameter is the initial value of the accumulator. So the 0 that you can see here, let sum is equal to 0, is to be added here. And then the function is actually pretty easy to use. I don't need the array, I don't need the index, I just need the accumulator and the item. And the callback function here just returns the new value of the accumulator after I processed the current item. So in this case, I have to do something similar to this. I have to return the new value of the accumulator, which is the current accumulator value plus whatever item I am iterating over. And again, this function can be written as an arrow function. So if I want to, I can just transform it like this. And then it's a function that does just one thing, and that one thing is returning a value. So I can even remove the curly braces and the return statement, and this becomes very, very concise. And if I think about it, this arrow function here looks really, really similar to a generic sum function, because this is a function that takes a number that I'm calling acc, but I can call it however I want. I can call it a. And the other function, item, the other parameter, item, can be called b. And this is just a function that I can call sum. This can become part of my arsenal of functions here. I can call it sum. And I can just replace this anonymous, I can just replace this anonymous arrow function with a reference to sum. So let's read this code again. The code here says, start with sum is equal to 0. Iterate over every item of the array. And for every item of the array, I want to accumulate the sum as increased with the current item. And at the end, I will have the sum. But here, I just have, hey, you know the sum? The sum is the result of reducing every item of the array to the sum of their elements, starting from 0. So as you can see, using those methods allows me to be a lot more declarative. I'm not saying step by step what the code should do. I just want the result to be shaped in a certain fashion. I want the even number to be the result of finding an even number on the array. I want the array of even numbers to be the result of filtering all the even numbers on the array. And here I'm summing everything as a result of summing. So these methods, as you are starting to imagine, allow me for a lot of code reusability, because I can use and reuse those small functions, and I can combine them even together. Maybe I will not show you how to combine those functions in a cool fashion, but you can reuse those function multiple times, and they make your code much more declarative and much more readable as soon as you get used to it. I know that maybe you're not used to that, and you're probably more used to the old-fashioned for loop. But as soon as you do exercises and practice a little bit on this kind of functional programming constructs, you will see that your code will benefit a lot. So reduce, I used it for sums, but of course, reduce can be used for anything. In fact, the reduce method can also be used to create every other function here. Let's try, for example, the map. Now, I'm going to do the map by using reduce. What does the map do? It takes an input array and creates a new array with the same number of elements, but all the elements are a transformation, the result of a transformation from the original element to the new element, all right? So in usual for loop code, we can do something like let's call new array, or mapped array. Could you just show the const function above for a sec so I can copy? Yes, of course. Was it this one? Probably was this one. So this is sum, and probably you understood that even the comparator function that we described below, well, that comparator function is actually, well, how do you say that? It's a difference, it's a subtraction. So even the comparator function, if you write it like this, could become just a subtract instead of just sum. All good, Angelo? Why doesn't ESLint show an error for declaring sum twice for you? I think that's because I have an error before that. So he stopped even inspecting everything after the first error. If I remove this thing, now I've got squares, which is redeclared. And if I remove this one, then sum is redeclared, etc., etc. So ESLint apparently is stopping as soon as it finds an important error here. Okay, so we want to create a mapped array which starts with an empty string, and then I will loop over the original array, let item of r, and the mapped array will contain the result of squaring the item. I think we had square. Oh, too dyslexic today. Yep. Okay, something like this. And then at the end, I will have the final array, which I can console log, for example. This works. This works pretty well. We already saw that we can instead write all this in a simpler way with map. But there's also another way, which is not a way that I recommend, but it's a fun game. It's a fun challenge that I really recommend you to try. You can rewrite this with a reduce function. How do you say that? Well, you create the mapped array as the result of taking the array and ask it to reduce. But this time, the reduce function doesn't start with a 0. It starts with an empty array, because the accumulator can be whatever you want it to be. It can be 0, it can be 1, it can be an empty array, it can be an object, it can be null, it can even be a function. It can be whatever you want. It's just an accumulator. So in this arrow function, I'm just going to tell what is the new value for the accumulator, and as the second parameter of the reduce function, I have to remember to start with the initial value of the accumulator, which in our case is an empty array. And then here I'm going to return whatever is the result of pushing blah blah blah. So since I shouldn't change the original value of the accumulator, but I should just return the new value changed. This is not mandatory, but I think it's better. Yeah, we can do something like return ack.push item. I'm not sure this works, however, because push, I don't remember if it returns the new array. Maybe not. Let me try. What happens if I have an array, which is empty, and then array push item? It doesn't give me the new array. It gives me the new length of the array. So this will not work. I have to push the item in the array, and then I have to return the newly created array. This I can do. Or if I don't want to mutate this accumulator with push, I can probably even use the concat or I can use the concat, but I don't think it's a good thing to do here. If I want to use concat, I have to concatenate two arrays together, and item is not an array, so I have to probably wrap the item into an array, and it's too complicated. Let's go with just push and return ack. This is fine. And that's it. This works. The reduce function is equivalent to this for loop. So as you can see, you never need a for of loop. You can always use a reduce function. And if you want to be even more concise, instead of using the reduce function, you can just use map, because this makes everything simpler. Oh, I forgot to do the square of the item. Oh, come on. Okay. This is it. Okay, so you can loop over the elements of arrays in so many ways, and I recommend you to pay extra attention, however, to these array methods. Reduce, for starters, because it's the most generic one. You can create a filter, a map, a for each, a find index, and even other functions that I didn't show you because they are less common. For example, there is a sum. Sum is a function that, as you can imagine, is just giving you true or false if there is at least one element in the array that is even. So the question here is, are there some elements who are even in the array? And we also have r.every, which asks if every element in the array is even. And this just gives you a boolean. But these are all different methods that you can use as they are, or you can just deduce. For example, sum is even will be true if array.find is even will give you a defined element, a non-undefined element. Or if find index will give you a number, an index which is greater than -1. So all of these are not really important. You can always use a different function. But I think it's best for you to have a look at all of them and maybe even reason and do exercises on how to transform one function, one method into another, noting that every single one of these methods can always be implemented with reduce. This is a homework that I'm asking you to do for next Wednesday. Please try to implement every single one of these array methods into the reduce method, or in any other way you can find. For example, the sum can be implemented as array find, etc., etc. And now we're going to coffee/lunch break. It will last 15 minutes. Probably you won't even have the time to cook anything. I won't. But still, you can enjoy your meal while we are going back to business. I will just speak and code. So, see you in 15 minutes. Bye. 15 minutes later. Hello again. I don't know you, but I didn't have the time to even finish the bowl of instant ramen that I prepared myself. But that's fine. I don't care about that. And it was still too hot. I'm not sure that everybody is already there. I don't expect you guys to be so punctual. So I'm going to actually continue the story about Facebook, because I don't want to pass the message that I hate Facebook. In fact, I love Facebook. I love the open source software that they create. I love React as a framework, which is made by Facebook. And that's why it was really, really disappointing for me to be rejected at the first interview. But also, well, the position, if I understood it correctly, was something like, hey, move from Italy to Dublin, and then you have to answer the phone and respond to angry Italian customers and fix the advertising engine in a way that pleases them. So it was something similar to, low-level computer engineering and customer care, which is probably not what I wanted and not a good reason to move from the beautiful Italy to Dublin. Even though I love Dublin, it's a beautiful city. Hey, you have a say in the breaks too. I usually just eat a sandwich and the time is enough. Yeah, but it's fine. I hesitated too much. I said, can I prepare myself something? Do I have anything? Do I have rice? No, this rice is not good. This is sushi rice. This is a rice that will cook for hours. And then I said, okay, I can do myself an instant ramen bowl. And the time was over. So I just had to prepare myself. The ironic side of the Facebook story is that a few years ago, while being an Inglorious coder, I was hired by Facebook to do a keynote. I had to explain tech leadership. So these are the slides that I created for my keynote. As you can see, it was sponsored by CodeEmotion, an Italian company, and Developer Circles from Facebook. So I had to explain to an audience of, I think, 100-ish people, what is it like to be a technical leader, and what's your responsibility, what you have to do, what you have to take into account, etc., etc. So yeah, I had another connection with Facebook at a certain point. They rejected me as a algorithm developer, but then they hired me for this keynote about tech leadership, which was more in my chords. How do you say that? Anyway, who's in the house? I see Bobby. Is there anybody else? Just want to make sure that I'm not starting with people that are still trying to hear. Yes, sir. Okay, cool. Very punctual, guys. Are you still eating? Do you need time to eat? Maybe you have your hands occupied right now. Your hands are busy and you cannot write code. So that's fine for me if you want to keep it slow. We are going to do another what? Up till 3 o'clock, right? So almost 2 hours. Here is not lunchtime right now. My stomach is struggling after last night's Indian food, lol. Okay. Yeah, Indian can be quite challenging. Okay. So let's go back to business. We already talked about reduce. There's also another companion called reduce write, which does exactly the same thing as reduce, but it starts from the bottom. So whenever you need to iterate over the array and reduce, you don't need to invert the array and then reduce. You can just reduce write and it will loop over the array starting from the bottom. I never saw any real interesting application of this reduce write function, except for when you're trying to build a special kind of function which is able to compose other functions together. This is a very advanced concept of functional programming, and it's a concept that I love. I usually teach it when I explain React, not because in React it is useful, but because I think it puts you in the proper mindset, I think. But still, it's a very optional topic, so I don't know if we will cover it. By the way, just for passing time, today is the 13th of March, and then we will have another lesson on the 20th, and then another one on the 27th. And then I don't know if we will finish the course by that time. Maybe not. Maybe yes. Maybe we want to add some more information that was not even planned, because I like to improvise things. But as I already told you last Saturday, I'm going to repeat it today, is that I could be busy starting from April or even before every Saturday morning with another course. So in that case, I will have to, unfortunately, move these Twitch lessons on Sunday morning, maybe at the same time, if that's okay for you. Otherwise, we have to find some other moments. What about the optional garbage collection, says Bobby. Yeah, garbage collection is also a very optional topic. I think you can pretty live without it. I already mentioned a little bit of what garbage collection is, and we don't have to go too much in detail about that. Garbage collection was part of the objects section. When I went through the objects, I said, this is important, you can skip that, it's optional, or you can read it if you want to. This is important, this is not really that important, this is not really that important. When I say that's not really important, I'm not saying you shouldn't read it. I'm saying it's not worth it for me to explain it to you during these lessons, because during my lessons I want to just focus on the most difficult parts and the most important parts. Garbage collection is a topic that is really, really easy to grasp, actually. If you look at how it works, it probably makes a lot of sense to you. But if you maybe read it and you cannot understand it, you can ask me, and maybe next lesson or next practice session, I can explain it better to you. But since it's optional, I don't want to waste your time in explaining something that it's not really that, you're not using it. The garbage collection is something that you are using every day under the hood while you're programming. And the cool thing about garbage collection is that you don't even need to know that you're using it. You are never going to use a method that says garbage collect or something like that. Java does it sometimes, but not in JavaScript. As far as I know, there's no such method, or you don't have to use it. So it's important to know that garbage collection exists. It's important to know that it's part of the higher level languages like JavaScript, Python, Java, C#. It's not part of C, C++. It's not part of assembler. It's not part of other languages like Rust or probably even Go. But that's the cool thing. If you have garbage collection, you don't need to care about garbage collection. If you're instead programming in a low-level language like C, C#, then you have to care about garbage collection, because since that feature is not there for you, you have to write your own garbage collector somehow. So that's why I'm not explaining garbage collection. Hope it makes sense. Reduce, write. And this is a very thorough explanation of how reduce works, but I think that if you understood how to do the basic for loop that increments a sum, then this will be nothing new for you, right? The sum starts with 0, the first number is 1, the current result of the sum is 1. Then on the second call, the sum is 1 currently. The second element that I want to add is 2, so the result is 3, etc., etc., etc. Just like the loop that we already saw multiple times. But this time we can do it with reduce, which reduces the number of lines to implement and also increases the readability and the claritiveness, let's say. Okay, we've got other things like array.isArray. This is a patch to a problem that we have in JavaScript. When I say type of this, it doesn't say it's an array. So how do I know the type of this array? How do I know that this is an array? Many people tried multiple times to come up with some clever solution. Now we've got array.isArray. That given an array will tell me true. Or if it's a string, will tell me false. If it's an object, tell me false, etc., etc. Do you really need to know if this is an array? Probably not. Not always. Sometimes. For example, let me go back to an old exercise that we did together, which I don't remember how is it called. Deep clone. Deep clone was an exercise, a homework that I gave to you, in which I wanted to clone an object, but not a shallow clone. I don't want to just clone every single property at the highest level of an object. I also want to come up, if I incur into a property that is itself an object, I also want to do a deep clone of that object. So the clone will be an actual clone and it won't have any references to the properties of the original object. So how did we do this? It was a recursive function. It's a function that at a certain point also calls itself. So in deep clone, I create a clone and then I iterate over the properties of the object, and then I have to check if the property is itself an object, then that property will have to be a deep clone of that property because it's an object and I don't want to just copy a reference. Otherwise, I'm copying the property as it is. But now that we know about arrays, we probably need to add an extra if. Because if the property is an array, object key, if the property is an array, I have to do something else. And I'm not going to tell you what. So this is another homework for you. Let's go back to the deep clone function. And if you haven't done this exercise yet, I really encourage you to do it right now. Right, well, not right now, after the lesson. And then try to also expect here to also have arrays. So my name is Anthony, I'm 38, I have one head, one torso, 4 limbs, and I also have, I don't know, a series of nicknames, like my GitHub nickname is Ice on Fire, and sometimes when this nickname is already taken, especially for online video games, I'm also Ice Under Fire, because it's the opposite of on, and also because when you're under fire, it means that there's people shooting at you. So I thought it was a nice name. So if I have nicknames, which is an array, I also don't want to just shallow copy a reference to this array. I want to deep copy this array. So there must be something here going on. And also, one other thing that I would like to ask you is, what if I put this if array after the type of object, object key is object? Will this still work? Or is it going to get unexpected results? So a couple of questions that I'm leaving to you. You will try to answer to these questions for next Wednesday if you want to. And if I'm not able to remember this thing, please tell me, hey, you were supposed to tell me about the deep clone function when dealing with arrays. Oh yeah, sorry, okay. It will happen like this. I'm 100% sure about this because I cannot remember everything. I cannot even remember what I just ate. Oh yeah, ramen. Okay. So we've got this function method array.isArray. Most methods supports this arg, which we don't care about. I really don't care about this arg. Never used it. Summary, and that's over. Okay. So I think we're done with this set of slides, probably. Apart from that, no, we've got destructuring and we've got date and time. Okay, there is this part about iterables, which I don't care. So this is another thing that I'm going to just skip at all. One small thing that I can tell you is that objects are not iterable. In fact, you couldn't do a for of loop on an object. Arrays are iterable. In fact, you can do a for of loop on an array. In JavaScript, there are some strange elements out there that are not really arrays, but they behave like arrays. In fact, they are iterable. So for those kinds of elements, you can always loop with a for of loop, even though they are not exactly arrays. I don't have idea why they made this thing so complicated, but apparently it's like this. And I don't think it's very interesting to see this stuff. String is iterable because string behaves like an array of characters. So you can for of a string and it will give you the nth character. Okay, good to know. Never iterated in a character like in a string like this. Also because a string can be converted pretty easily into an array and then you can iterate over the array. How do I convert the string into an array? str.split. Given the empty string, and now it becomes an array, and I can just iterate over the array instead of iterate over the string. So not really that useful to know that the string is iterable. Calling an iterator explicitly? No. Okay, no, I don't think that this is important. If, of course, you're encouraged to read everything and to do exercises on everything, but I'm not going to spend time on this because I don't think it's important right now. These are optional, advanced concepts that maybe you can read by yourself either now or at the end of the course, but they're not important right. Nobody is going to ask you anything at an interview about iterables, and nobody is going to ask you to use this information when you are working in the current workplace. I never use it, and I have some experience, a few years of experience in both backend, front end, and multiple years of JavaScript. Never use this information. Map and set, and this is another kind of information that could be optional. I already told you that in languages such as Java, I will show you, Java Collection API. Okay, this is not the latest version, but I don't care about that. In Java, you have a huge tree of things that of type thing, etc., etc. The collection is a sort of iterable thing in Java, and a collection can be of different kinds. For example, an abstract list, an abstract queue, an abstract set, an array dequeue, an array list. Array list is pretty used in Java. A vector, a tree set, a stack. Let's see the queue. Where's the queue? There's not just a queue. There's a linked blocking queue, a priority blocking queue, etc., etc. In Java, you have this zoo of multiple types of collections that all share the fact of being collections and being iterable. And you have to know some or most of them because there's a huge difference between a list and a set and a map and a stack and a queue, etc., etc. In JavaScript, as I already told you, there's not much difference. You just have arrays, and arrays behave like queues, like stacks, or anything else. It depends on how you use them. They are less performant this way because queues in Java are specifically designed to be performant when used as queues. But we don't care too much about performance in JavaScript. We don't care. We care more about reliability and easiness of development. But then, at a certain point, JavaScript introduced two new kinds of collections that you can use if you want to, or you can just completely skip them if you don't need them. I never use them in my life. Even now that they are available, I never use them. Because they look like an object as for the map, and like an array as a set, but they have some extra properties that I usually don't really care about. But if you really, really care about those properties, then you have to use map and set. What are these properties? Well, a map is very similar to an object because it's a key-value pair, but in a map, you can use keys that are not just strings. So you can put numbers, you can put booleans, you can probably even put null values. So if you really want an object that can store keys, not as strings, but as numbers or booleans or anything else, then you could use a map. The map has a strange syntax. It's a little different and more complicated than the object. As you can see, map must be instantiated with a constructor, new map. And then when you want to add an item or just to replace an item, you have to say map.set given the key and given the value. And if you want to get the item given the key, you have to say map.get given that key. And then you can also ask for the size of that map. So it's a more complex object. If you can stick with objects, plain objects, maybe it's better. But if you really, really need to have keys that are not just strings, then just use a map. Map of key, as you do with objects, isn't the right way to use a map because something strange works, happens under the hood. So you should always use get, set, and also size. What about blah, blah, blah? Okay, if you want to iterate over the map, you have to ask for the keys of the map, the values of the map, or the entries of the map, blah, 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 blah. So you can read it by yourself. I don't think that's important right now. Sorry. And then we've got the set. The set is really similar to an array because it's a collection of values without keys, just stored in certain position. But the set ensures that every item in this collection is unique. So sometimes you don't need this behavior. In an array, yes, I am allowed to say something like let r is equal to apple and also apple again. And this doesn't bother me that much. If I want to avoid duplicates, I can still write some code that checks if the element is already there in the array. And if it's not there, I'm going to add it. Otherwise, I'm not going to add it or something like that. Or I can use a set. I don't know if it can be called set. Let's see. Yeah. And the set can add values like apple. And now the set contains apple. And if I add apple again, it just contains one apple. So it just spares you that one extra if that checks if the apple was already there. And then the set is iterable, which means that I can iterate over it. Maybe set values. Yeah, but set values doesn't give you an array. And if you want to iterate over the values of the set, you should probably use the for of let item of set.values maybe. Let's see if this works. Console log item. Yeah, it's printed apple. And is set iterable itself? I don't need to put values. Yeah, still true. So maybe there's also a way to transform this set into an array, but I don't really care about this because I never use a set. I probably just use a set only once. I needed an array that didn't contain duplicates. So I did something like I had this array, I converted it into a set, and then converted it back into an array. So it was an array with no duplicates. But it occurred to me only once in my life. How do I iterate over the set? Let value of set, which is what I've done so far. And since sets are also iterable, you can use the for each, the map, etc., etc. Okay. That's it. Not going to go even further on that. And especially on this, they also added weak map and weak set, which has something to do with garbage collection, because weak set, if it refers to something that was destroyed, will probably then not have that element in the set anymore or something like that. I never used it, and I don't think you will ever need to use it, really. Trust me. But of course, just read it for yourself. I'm pretty sure that by now you have all the tools to understand these concepts by yourselves. So there's a lot of work to do. Not just the homework that I passed to you. There's a lot of things to study by yourselves. There's a lot of tasks to perform. And there's also the homeworks that I give to you. The more we go further, and the more the burden of learning is left to you. Because you cannot be spoiled by a teacher that explains you every single thing one by one. Your mind will start to become numb. Instead, I want you to proactively start inspecting and learning things and finding things. And I already saw that you are doing it. In fact, sometimes you share YouTube links and docs and other courses even, which seem interesting to you. That's the spirit. You have to do this. Try to think critically. Don't just give my word for granted. If you want garbage collection, read about garbage collection, study garbage collection, and if you want a real challenge, create your own garbage collector. My job right now is just to tell you that the garbage collector exists, and that's it. Object keys, values, and entries. This is interesting. If you have an object, let's say let obj is equal to usual stuff like name Anthony and age 38. I want to iterate over the properties of this object, and I know how to do this. I have the for in loop, let key in obj. But there's also other ways. In fact, nowadays, this is a new feature, we've got also the object that is able to do multiple things. We already know that it's able to do an object assign, which was able to do a shallow clone of an object. But we also have other things like keys. Object keys of some object will give you an array of all the keys inside of the object. So once you have this, you can use map, you can use for each, you can use reduce, you can use filter, and all the other methods that apply to arrays, because this is an array. Object keys of object is an array, so you can use whatever you want. Apart from keys, we also have values, which of course is going to give you only the values and not the keys. And if you want both, you can use object.entries, which will give you a matrix. It's an array of arrays. Every entry is an array that contains the key and the value, if you really need this. Okay, so this is a way to transform somehow an object into array and iterate over the array instead of iterating over the object. I use it quite a lot because I don't like the for in loop. So I usually use object keys or object entries to iterate over the properties of the object as an array. Blah, 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 blah. Okay, here they are showing you a cool way to transform an object. So if you want to transform an array, you already know that you can use map. But what if you want to transform an object instead and having all the properties, all the property values change somehow, just like with an array? Well, they are suggesting a cool algorithm here, which uses object.fromEntries, which, as you can imagine, it's the opposite of object.entries. So if you have, if you have an object.entries will give you this array of arrays. And let's call it entries. Entries is object.entries of obj. And now entries is this array of arrays, which are name, Anthony, age 38. I don't know if you really want to know this, but when the array has a fixed size like this and it contains very specific data, it is usually called a tuple. But that's it. Okay, so object.fromEntries takes an array of arrays like this entries object and creates the objects. Okay, so it's a way to transform the object into an array of arrays and vice versa. And this way you can somehow unwrap the object as if it was an array. Object entries prices becomes an array. And in the array, you're doing this kind of thing that is strange. They are showing it to you right now. Strangely enough. And then you can change keys or values, and then you can transform everything back again into a from entries, and that's it. But this is already a little more advanced. It may look difficult from the first sight, but becomes easy to understand after you use it once or twice. We can make powerful chains of transform this way. Yes, but this is also using something called destructuring, which has not been explained. And it's explained later on. So I don't really care about this object from entries. I think that the tutorial made a small mistake showing you something that they didn't explain. In that example. So let's instead show you this other very, very cool topic that is applied to both objects and arrays. So let's create a new file here, destructuring. This is something that I was waiting for so long from JavaScript, and then it was introduced in ECMAScript 6, and then it was even it became even better in future releases of JavaScript that we can use nowadays. So let's say that I've got an array like const r is equal to, let's put A, B, C, and D. I think we can stop here. Okay, this is an array. How do I get the first element of the array? I know how to do that. I do const first is equal to array of 0. And how do I get the second element in the array? Const second is equal to array of 1. And the third one, you understood. You know what? I'm gonna stop with 3 elements. Okay, that's it. But now we've got a new syntax here, a new construct in the JavaScript syntax, which allows me to get these 3 items from the array and give them exactly the same name, but in one line of code. How do I do that? It looks like the declaration of the array, but flipped out. It is called destructuring because I know the structure of the array and I am destructuring it into its constituents. So I can say const array containing first, second, and third is equal to R. This line of code is equivalent to these 3 lines of code because I can read it like this. I can say the array, the variable R, is an array, so I have to use the square brackets, which contains 3 elements, first, second, and third. And I will call them like this. And in one line, I'm declaring the 3 variables at the same time. Not only, if the array has a 4th element, this still works. It works exactly as this one. I'm just saying that the array is an array that contains, well, at least 3 elements that I will call first, second, and third, and I don't care about the 4th element. Let's try it out. So I'm going to copy this. Okay. This is the array. And if I do, I will write it again because I am too fast. Const first, second, and third is equal to R. If I do something like this, then I've got a new variable called first, which contains A, a new variable called second, which contains B, and a new variable called third, which contains C. And what about D? I just ignored it. I didn't create a variable for that element in the array, because I wasn't interested in that. Okay? So first, second, and third. If I know in advance the dimension of the array, or at least what is inside of the first elements of the array, then I can do it like this. Of course, first, second, and third are just words that I came up with myself. As you can see, they are just variable names, and I can call them however I want. I can even call them A, B, and C. That's fine. It's variables. You name them. Okay? So this goes with arrays. And with objects, it's exactly the same. So const obj is equal to, let's say that this has A, which is equal to 1, and B, which is equal to 2, and C is equal to 3, and D is equal to 4. This is an object. And if I want to get the property A, I can create something like, well, of course, I can do obj of A, and that's it. But if I want to save it into a variable, I can do something like const A is equal to obj A. This should not even be called A. This could be first prop. Okay? The first prop is obj of A. The second prop is obj of B. And the sorry guys. And the third prop is obj of C. But this is not destructuring. Can I do this in one line with destructuring? Yes, I can. That's why I'm here. So I can say that the object is, I'm writing from right to left, an object. And instead of these objects, there are properties. But I'm actually interested in the property called A, which I will call first prop. So I'm using column. And I'm interested in property B, which I will call second prop. And I'm interested in property C, which I'll call third prop. So as you can see, the syntax is slightly different from the array, because here I have to also declare which property I'm referring to and what the name of the variable should be. But not always. In fact, if instead I want to use a variable which has exactly the same name of the property, like this case, for completeness, I'm going to put also C. If I want to do this, then my destructuring would look something like A that I will call A, B that I will call B, and C that I will call C is equal to destructuring the object. But as you know, in objects, there is a shorthand in which when the name of the key is equal to the name of the value, I can just omit one of the two. And this destructuring looks a lot like the destructuring that we have in arrays. Okay, so this is actually the usual destructuring that I do. And destructuring is quite useful, especially in some frameworks like React. Destructuring can be performed anywhere, even on the parameters of a function. For example, if I have a function sum that instead of accepting two numbers accepts an array of numbers, and if I know that this array contains exactly two elements, then instead of writing R, I can write an array that contains A and B. And this is destructuring in place. This is exactly like saying sum of R, in which I know that the A is R of 0 and B is R of 1. Or using destructuring, instead of doing these ones, I can say const A and B are equal to R. And as you can see, since A and B are the same thing as R, you can just place them here and remove the reference to R. So this is destructuring in place on the parameters of the function. Nothing really difficult. It's actually, probably it's difficult to understand what you can do and what you cannot do. But that's why I'm asking you to practice, because that way you will know by yourselves what is it that you are able to do and what's not. Everything that makes sense to you is probably now doable. And if everything that doesn't make sense to you is probably not possible. And that's it. Maybe your common sense on this topic didn't evolve yet, but you will see with practice that this common sense will refine itself. So this is destructuring of arrays. So I can do this, first name and surname. If I have an array with two strings, John and Smith, I can destructure the array saying that the first item in the array, I will call it first name, and the second one will be called surname, because I want to. And it's the same thing as saying let first name is equal to r of 0, let surname is equal to r of 1. I don't know what they're saying. Okay, yeah, if you have a string, you can split it so it becomes an array, and in that case, you can destructure it, of course. Destructuring does not mean destructive. In fact, nothing gets destroyed. It's just a shorter way of taking the elements from an array, but it's not changing the array at all. It's just taking some values from the array and placing them into variables. You can use, as I already started mentioning, I didn't remember that, you can use empty spaces if you don't need the second element. I would probably never do this, but if you have this array, Julius Caesar, consul of the Roman Republic, and you don't care about Caesar, you just care about Julius, and you care about consul of the Roman Republic, you just leave an empty space. Or you can just provide a variable that you're never going to use, and that's fine. What else? You can destructure a string apparently, and it works into an array. It becomes an array. You can destructure a set, and it becomes the three variables. I didn't know about that, but never going to use that. And okay, here it's going to split things and placing the items as properties in an object. So you've got the user, and you can even say this first element in the array, when split, it's going to be placed as user.name, and this is going to be put as user.surname. Never use this one, but could be helpful. And etc, etc. I think that the more you use it, the more you understand it, and it's probably better to just use it in some real life scenarios rather than just looking at these examples. This is another really important part. It's another operator which is usually called the spread operator. Here it's called also rest. I don't like it as rest. We use the variable rest, but so what is the spread operator? In arrays, if I have an array like this one, I can do something like this. Const first, because I'm interested in the first element. Const second, because I'm interested in the second element. And all the rest, all the other elements, which are two in this case, C and D, I can put them in a separate array, in a sub-array, which I can call with ... rest. Or with any other name, because this is just a variable. If I don't put these three dots, what happens is that first will hold A, second will hold B, and rest will hold C, just like these ones, first, second, and third, held A, B, and C. This is not what I want. If I put those three dots here, first is A, second is B, and rest is an array that contains everything else, all the rest. Let's try it out. So here we are with the array. And if I now destructure first, second, and rest with the spread operator, I will see that first, nothing new, is A. Second, nothing new, it's B. And rest is not just one element. It's an array containing the rest of the element. It's exactly the same thing as saying slice from 2 to the end. So this is a more declarative way to just say that the array is an array that contains a first element, a second element, and then the rest. Without destructuring and without these rest parameters, you have to say something like this. Const first is equal to r of 0, const second is equal to r of 1, and const rest is equal to r dot slice 2. But in this case, you can have everything in the same line, very, very declarative. You're just saying what is the shape of the array, not how to slice it, right? And the same goes with with objects. You can even use this with objects, and it behaves exactly the same. So if you have an object like this one, and you care about A, B, and then you want to place everything else inside of a different object. I need to put a fourth prop here. No, actually not, because I already have a fourth prop here. Yeah. Okay, so in this case, I can do const A, B, C, not even B, not even C, A, B, and the rest. Let's see what happens in this case. So I'm creating an object, and the object is this one. And now I'm going to use this destructuring with the object spread operator. And I cannot because the thing has already been declared, so I'm going to do it again. Okay, so A has a value of 1 because A is a variable that I just created which refers to the A property of the object. B, same thing. And if I look for rest, I'm tired, so I'm looking for rest. Then you see that we have a sub-object containing all the properties that I did not destructure in here. Okay? The object spread operator is a feature that for quite a long time, I think for 1 or 2 years, was not available in JavaScript. But it was still a proposal. They wanted to add it to the language, but they were still unsure. Facebook instead started using it in the framework React as if it was already part of the language. And then finally it became part of the language, so we can now use it every day. Just a piece of history of the object spread operator. This started being just a proposal. The spread operator on arrays was already there, but they were not sure on if they wanted to include the object spread operator too in the language. And then finally they decided to do that. Maybe also because Facebook pushed on using the object spread operator because it was so convenient in the framework React. Okay. And we can do so many other things, of course. For example, do you want to clone an object? If you want to clone an object, you can do something like const clone is equal to object assign, starting from an empty object, obj. If you remember, this is a method of this object that takes a target, a destination, which is usually an empty object because we start with an empty object, and takes one or multiple sources and clones shallow every single property of those sources into that destination, and that destination is also returned. But now, with the object spread operator, I can even write it like this. Const clone is equal to spread the object. That's it. This is a shallow copy of my object. And that's why it's called spread, because these 3 dots take every property of the object and, well, these 3 dots, they spread the properties of the object inside of this new object. Clone is a new object. Clone is not the same object. It's an object that... What am I doing? Sorry. Clone strictly equals not... It's not the same object. It's a clone that contains the same properties. with a shallow copy. And we can do the same with arrays. So if I've got an array which contains A, B, C, D, how can I? No, I wanted to, okay. Const array is equal to A, B, C, D. If I want to create a copy of this array, I have multiple ways. I can call it copy, just to not mess up with clone. And the copy could be r.slice starting from 0, because if you remember, this is going to create a slice of the array starting from a certain index. But if I start from index 0, then the slice will actually contain every single element of the original array, starting from 0 to the length of the element. So copy is exactly the same. But with array destructuring, I don't even need to use slice. I can just do something like spread the array inside of a new array. Spread the elements of the array inside of the new array. As you can see, it's optional. You can still use slice, or you probably don't even want to copy an array in your life, but you can do this. Okay? So destructuring is quite important, and I really hope that we will do some exercises on this, because it probably requires a bit to get the hang of it, but it's very, very useful. As you can see, now it's going to talk about object destructuring and probably also the object spread operator. Yep, the rest pattern. I don't understand why it's called rest. Why is it called rest pattern here? But I'm pretty sure that in literature you will see it as object spread operator, the spread syntax. Blah blah blah. Yeah, actually, the spread operator can also be used on functions, which is probably something that will give you a aha moment. I hope so. Let's try to create a function that prints a message. A function that prints a message will do a console log of that message. Or maybe even an alert or whatever you want. Nothing fancy here. But what if I want to print multiple messages? Well, messages could become an array in that case, and I could iterate over the messages and console log every message. So for example, I can do it with the, what do you want me to do? For of operator? Or do you want me to use the for each? Or you tell me, you decide. For each. Okay. So messages dot for each. And inside of this method, I will call a callback function, and I'm going to write it immediately as an arrow function. So for each message, I'm going to, well, console log the message like this. Okay, but this is going to print the messages, and this is how you use this function. You do print an array of messages such as hello world and how are you, okay? But as you know, there are some functions out there that allow you to print, to consume any number of parameters. One of these functions is console log. If you remember, console log allows you to add any number of messages, any number of strings or expressions. You can just say message 1, message 2, right? You can do this without wrapping everything inside of an array. Another function that does the same is totally lost it right now. Because, but the object assign, of course. Object assign. I already told you that object assign needs a target, so usually the empty object, and some sources, more than one if you want to. And as you can see here, sources is written with the triple dot. So with the spread operator. And this is something that we can use too. If we want to print all the messages without wrapping them inside of an array, we can just use those 3 dots here. And this allows me to take all the parameters in the print function and place them inside of an array, which will be iterable. So I can perform a for each on messages. That's the only thing that I need to do in order to have a function that gets more than one parameter, any number of parameters. Let's try with the sum function, okay? I want to create a function called sum that accepts not just A and B, but every number that I have as input. So if it was A and B, it would be something like this: return A plus B. And this is pretty easy. But if I want to make a sum of any number of parameters, then probably I can do something like this. Function, let's call it differently. Let's call it, I don't know, sum many, okay? And here we can spread all the numbers that we want to sum. And just by adding this spread operator, I can use sum many like this, sum 1, 2, 3, 4, 5, and these will be collected into an array called numbers inside of the function. And now that I have this array, I can sum these numbers. How can I do this? Multiple ways, but one way to do it could be to use the reduce function. So I can do something like, hey, return whatever comes up as the result of numbers.reduce. I have to place a callback here, but I know what callback there is. It's sum. I can use sum starting from 0. I know it's a lot. It's a lot to take. But if you try to replicate this code, and if you try to, to reproduce the same train of thought or to experiment in multiple ways, you will eventually have a gut feeling of how this works. Of course, I'm using function declarations, but if you want to, you can also use arrow functions. So I can turn this into an arrow function, and it's fine. It will be more concise, nicer looking. And also sum many, if you want to, it can become const sum many is equal to an arrow function that, given any number of numbers, will return numbers reduce, which actually doesn't even need any curly braces or even a return statement. Shall we try it? Let's try it. Okay, so I've got the function sum, which is an arrow function that sums two numbers together. And in this second line, I'm using two concepts that I explained today. The first one is the reduce array function, array method, which, as we saw, in its simplest form can be written like this. Reduce accepts two parameters. One is the callback function, which will be invoked at every element that is being iterated over. And the second parameter is the initialization of the accumulator. The accumulator here is the number A. And every iteration of the array, I'm just returning the current value of the accumulator plus the current element in the array. But I'm using the generic sum function because I can. I don't need to specify a different kind of function in the reduce function. I can just use sum. And the second concept is the spread operator on function parameters. If I want to use a function with any number of parameters, I can by just remembering to use the triple dot here. So all these parameters will be then collected into an array. If I don't put these three dots, numbers is the variable that refers to the first element, which is not what I want. I want an array of all the parameters. That's why I need the spread operator. Let's see if it works. 15, because 1 plus 2 plus 3 plus 4 plus 5 is 15. Looks like magic. I believe that it looks like magic. And you know what? It looks like magic even for experienced programmers. This is actually part of the advanced courses that I give to experienced developers whenever I teach them advanced JavaScript or advanced React. Instead, I'm gifting to you these advanced concepts because I want you guys, the ones that gave me your trust, to have this advantage over everybody else. You want us guys to suffer? Yes, I do. I really, really do want you guys to suffer. And I told you from day 0. You remember this slide? Not the one. Yeah, I'm never gonna give you up. But also this slide here, I said it's a bootcamp. It's tough, it's long, and it cannot be exhaustive, so I cannot tell you everything that you need to know, but I am giving you the proper mindset and the proper tools to learn things by yourselves. So yes, it's tough and it's long, but also because I want you to prepare for the real world. And if you suffer now, you will suffer a lot less outside of here. But if you suffer too much, just tell me. I can slow down, I can repeat things. It's a controlled environment here. I don't want you to suffer so much that you say, okay, it's not worth the while. It must be worth the while. You must have fun suffering, but having fun. Okay, there's a gotcha if you don't specify a let. These are variables that should be declared. Okay, they're trying to declare the variables and then destructuring. No, this doesn't work. You have to declare the variables in the same line in which you're destructuring. Okay. Oh, and if you put parentheses, in that case, it works. Okay, I didn't know that, and I'm never going to use that information. Nested destructuring. Yes, you can even destructure nested. It becomes difficult to see and understand, but you can use it. So for example, if you have an object called options, which contains size, which it's in turn an object, and then it has items, which has an array, and extra, which is a boolean, you can destructure options by almost making things on the opposite. You say that options is an object that contains a size, which is an object that contains two properties that I will call width and height. And it contains items, which is an array that contains two items that I will call item 1 and item 2. And it has a title, but it doesn't. So by default, if there's no title, if it's undefined, I will use the default value of menu. This is really, really difficult to read and to understand. I usually don't destructure multiple nested things on the same line. If I need to destructure things, I will do it in multiple steps. So for example, let's see these options here. If I want to check, let's say, the donut, if I want to get the donut and put it into a variable called sweet, I can do something like this. I can say that options can be destructured into items. Yes, options contains other things, not only items. It also contains size and extra, but I don't care about those. I just care about items. And items is an array, so I can destructure items as an array containing something that I don't care about and the sweet that I care about. This can be performed in 2 steps. So I'm destructuring the object getting the array, and I'm destructuring the array getting the second element and saving it as sweet. So now if I console log sweet, it should give me donut. Shall we try? Blah, blah, blah. Yep, it gives me donut. But if I want to, I can destructure everything on the same line. Don't say it's good, probably not. You're just saying in the same line that items is an array that contains something that I don't care and something that I care called sweet. And in that case, I can remove this second line because this just works. Oh, yeah, of course. always redeclaring things. Yep, still works. But it's actually pretty difficult to see. And also, when I save the file, Prettier decides that this thing should be on its own line. So it makes it even more difficult. And now a thing that was 2 lines long is actually 3 lines long. So probably it's not a good idea to do something like this. Maybe we can just have, again, 2 steps, and these 2 steps will easily be located in their own line and will be pretty readable, okay? A small note on the indentation. You probably noticed this already, but with objects, properties are usually separated from the curly braces with a space. And in arrays, this doesn't happen. The array, the elements in the array do not have this extra space on the borders. It's just a convention. You can change it in the Prettier configuration, I think. But it's what I'm used to right now. And it's the standard, it's the default. Okay, I think we're done here. One last thing probably that I would like to make clear is that the spread operator on functions can be used exactly like the spread operator on arrays, which means that you can have first number, second number, and then all the other numbers, okay? You don't need to have only one parameter here, which is the spread operator. You can still have any parameters that you want to process separately, and then the spread operator, which will process any other parameter collected into an array. It's not this case. I don't care about this case, but it is feasible. And another thing that I would like to stress about, that what I would like to pinpoint, is that this spread operator is not a miracle, unfortunately. For example, I would love to have something like, hey, from the array, give me the first element, give me the rest, and then give me the last element. It would be nice to have the first and the last element in their own separate variable and everything in between put inside of a sub-array called rest. But this will not work. Unfortunately, after the spread operator, you cannot put anything else with arrays. So you cannot destructure the last element like this. There's no way you can destructure the last element with spread operator. That's why it's still important and relevant to use the slice method, for example. This will not work. Rest element must be the last element. So if you want the last elements, you can destructure the first, and from the rest you can still do rest slice -1. Yeah, this is giving you the last element, but it's inside of an array, so I can get the first element, and this is D. I don't know if this was too magical for you, but if you have already made some exercises on slice, you should know that you can use negative indexes, so you start counting from the bottom, not from the top, and slice will give you an array. And even if the array has one element, it's still one array containing one element. And if I want to get that first element from the array, I can use the bracket notation. So I'm doing lots of things on the same line. If you want me to split this thing into multiple statements, I can. Maybe it's more clear. Let's see what the people say. We have time. We still have 1 whole hour. That's fine. Okay. That's for Bobby. But Bobby is competitive. So I also want to hear from someone else. This is the right moment for you guys to say, hey, I completely lost you. I have no idea what you're talking about. And I will probably watch the stream later on at half of the speed in order to understand anything. It's okay, I guess. Okay. All right, I don't know if there's anything really. I'm okay by now. Awesome, good. You're processing these things pretty well, and I'm actually proud of myself, and I'm also proud of you, of course. But I'm also proud of myself because apparently, if this is not too abstract to you, it means that you already built some solid foundations. Sometimes I explain things to an audience that should already know some JavaScript, and they don't understand these things as easily as you because they learn JavaScript from experience. They tried things around, but they never stopped and looked at documentation or did any exercises. They just learned from their experience. Learning from experience is probably the fastest way to learn, but it can also give you some bad lessons that get engraved into your head and you cannot go past those lessons. Sometimes I see people that say, I always did like this. Okay, but why? I don't know, because it's tradition. I always did like this. I didn't even know you could do things in a different way. That's why I think that any tutorial, any course should have the good balance between practicing, doing experience, maybe even creating real life applications, but also some theory, some experimental theory. I don't want to say that we should learn everything by heart, but we could just learn that things exist. We can learn roughly how they work, and we have to learn how to do experiments on those things, or how to look on the internet to get to the truth, to get to the truth. It's a little abstract for me right now, but with practice after the lesson, it'll be okay. Yes, I'm pretty confident that it will be like this. Anyway, really, kudos to you guys. Congratulations, because so far we are at lesson, did I say 19? So it was supposed to be the second to last or third to last lesson, and you're still here with me, and I think you understood everything that we made so far, and you will be able to understand this stuff too. So, very well done, guys. Okay. Encore. Date and time. We never spoke about dates and times. But it's important. In fact, look at this tweet. Elon Musk, I'm putting people on Mars. Developers, fantastic, more time zones to support. Dates and times are really, really tricky. They are starting to get less tricky, but they are still tricky. If you want to create a date, well, a date could be a string. It could be something like 2020 or 2021 0313, which is a year-month-day format for today. We could also write it in the opposite direction, 13/03/2021, and this is exactly the same date, but it's actually a completely different string. Or if we want to go with the Americans, it would be something like this, month, date, and year, which makes completely no sense to me. Because either you go from the bigger to the lowest number, to the lowest resolution, or the opposite, but you don't mix month, day, and year. I'm tempted to say it's the 13th of March of 2021. It's not the March of 13 of 2021. But still, who am I? Who am I to say anything about dates? Okay, and what about the time? Well, there is a standard format which actually prefers this one. So it's like this, 2021-03-13. And then if you want to also specify the time, the standard string format for this is to use a capital T as a separator. And then you place the hours, which in my case will be, well, it's 13:59 right now. Hours, colon, minutes, colon, seconds, let's say, I don't know, 42. dot milliseconds, which are usually 3 numbers. And then you also have to specify which is the time zone that you're working on. So if we don't care about the time zone, or we want the time zone to be the Greenwich one, we are talking about Zulu time. And because it's Zulu time, we just add a Z. And this is a date in standard format in Zulu times. It's almost 2 o'clock Greenwich time, UTC time. But it's not. It's actually 2 o'clock my local time, which is 1 hour past Greenwich. So in that case, I'm not using Z, I'm using plus 01:00. And this is my time zone. This is exactly the current date. Well, not anymore because it's 14. Let's say like this. Okay, it's exactly 14 sharp my local time. This is how you present dates on strings, with strings. But what if I now want to manipulate the date? What if I want to format the date and show it as maybe in the American way, month, day, year, or use the slash as a separator? Or what if I want to add a day to this date? Or what if I want to, I don't know, subtract minutes or format it into a different way, or even sum dates together or compare dates together? I don't want to compare strings. Well, that is why every single programming language has a special object, which is the date. And if I say const date is equal to new date, I'm creating a special object that I can inspect. If I ask for date, it's just going to print a string representation of my date. And apparently the string representation is the American way because it's Saturday, it's March 13, 2021, it's 14:01:51 in GMT 0100 Central European Standard Time. But the date is not just a string. And if I... Wait a second. Okay, I received a message from Twitch. Are you still there with me? Seems strange. Did you lose connection? I'm sorry, I asked 2 questions. Okay, working fine for me. Okay. Twitch said, hey, you can manage your things directly from your phone. Yeah, I'm doing this. Thanks, Twitch. Okay. So the date, as you can see, is an object that has a string representation, but also has lots of different methods that I can use. For example, I have getDate, which gives me the day. It's 13, the 13th. And we've got getMonth, which will give me 2. Why 2? I have no idea, but months starts from 0. So January is 0, February is 1, March is 2. And this doesn't apply with the date. 13 is the 13th of March. No idea why they decided the month to start from 0. But now it's like this in every single programming language. And nobody is going to change that because of backwards compatibility. What about the year? Date get year. We have the year. But the year is 121. What is this? Well, it's some sort of strange representation of the year that I will tell you in a while. There's a full year instead, which gives me the result that I expect. And as you can see, also the year starts exactly where I expect it to be, 2021, because this is the year 2021. But the month, I have to add a +1 in order to have the real month. And then, of course, we've got also the seconds. We've got the hours. Okay, we've got the minutes. And if I want to format this date in the old way, I can maybe create a template literal in which I say, hey, let's put the get date, because I'm Italian and I start with the day, and slash, and then let's put the month keeping in mind that the month, however, has to be incremented by 1 to give me the right month, slash, and now I'm going to concatenate the year, but using full year. And now I've got a date formatted, at least the Italian way. But I also see that usually we write 03, not just 3. So I also have to do some more stuff in here. Maybe I have to say, hey, if the month is just 1 digit, then add an extra 0, both for the month and also for the date. So this is becoming a bit cumbersome. Just to format a date, I'm spending too much time in concatenating strings and maybe even do ternary operators and if-else statements. It's too much. So as you can see, the date object is powerful because it allows you to create dates. Crying in Excel when thinking about dates. Yeah. That beautiful meme about dates in Excel. Yep, that's it. Taken directly from Friends. 12 dot 5 12.5. Oh, 1:12:19, 12 p.m. Why does get year even exist? Would I need how many years have passed from 1900 anywhere? I don't know. I never used it, but it exists for some reason. This was not exactly what I thought about, but it's actually similar. Yeah, sometimes in Excel, dates and numbers are mixed up together. In JavaScript, it's not exactly the same. In fact, we have another cool thing here. We can say date.get, I don't remember. Well, we've got milliseconds, but we don't care about that. Get time. Date.getTime gives me a huge number. This huge number is called a timestamp, and it's a unique number that once converted into a date is exactly a date. Unix timestamp. If I enter the timestamp that I copied before and I try to convert it, it's saying that it's a date relative to 6 minutes ago. It's Saturday, 13 March 2021, 14:01:51 in GMT 01 local time, or in UTC GMT 00 Greenwich time, Zulu time, it's actually 1 hour before 13:01. Okay, so the timestamp is a unique number that identifies the current date. The problem is that it's not really that easy to read, but the timestamp is also very, very useful because it's a number, so we can do calculations on that. For example, if I want to check how many years I have, I can say, hey, do a new date and subtract the date I was born, and it will give me a timestamp which I can convert, and I'll see how old I am. Can I actually subtract dates? Let's find out. New date minus date. Yeah, apparently it does. And every single time it gives me a different result. Why? Well, because the date that I created before is fixed, but the new date, every time I ask for a new date, it just gives me this date, which is completely different from 1 millisecond ago. Okay? And well, this is the number of milliseconds that passed. And I don't know how many seconds or minutes or hours this is. So I need still to perform some calculations. For example, if I have this, I have to probably divide it by 1000 to have the seconds, and I have to divide it by 60 to have the minutes. And I'll say that 7 minutes have passed since the last time I created a date. In fact, it's 14:09 my time, and I created this date at 14:01:51, so 7-ish, 8-ish minutes. So I have to perform some calculations nonetheless. And so Bobby was referring to 1900. What is this? Well, if we started counting time from, I don't know, the birth of Jesus Christ, this number would be pretty long. If we started counting numbers from the birth of the universe, from the Big Bang, then probably this number wouldn't even fit on our computers. I don't even know that. So there is a convention in which programmers decided that the world started at a specific date, which was epoch. Let me see here. Epoch is the name of the start of the world in programming. We don't really care about going before 1970, if I remember correctly. This is just, wait a second. Epoch disambiguation in computing. This is what I wanted. So before 1970, we don't really care about dates for some reason. Probably because computers were not even there at that moment, or they were too archaic. I don't know. But if we want to mess up with dates before 1970, we probably need to use them in some other ways. When you create a date, and you don't specify anything, this is the current date. But you can specify something inside of here. I don't know what happens if I put this. This is the timestamp. I can create a date from the timestamp. And if the timestamp is exactly the number 0, then the date will represent the birth of the world according to programmers, which is the 1st of January 1970 at 1 o'clock, at least my time, so 0 o'clock UTC time. And if I want to create a date from this timestamp, which I created before, new date given this, it's exactly the same date as we saw before. So we can use timestamps interchangeably, knowing that the most ancient period in time is not 0 BC, 0 DC, 0 AC, I don't know how is it called. It's not even the birth of the world. It's actually an agreed date and time, which is the 1st of January 1970. And I'm using it on my website. Yep. In the Y section of Inglorious Coders, I wrote, it's Unix time 1615641169, the age of information. And every time you refresh the browser, it tells you a different time. Just because I'm a nerd. Okay, so dates seem to be quite tricky, and the date object is probably not the best solution yet to deal with dates. If you create a date like this, this is now. It shows the current date and time. If you create a date given the milliseconds, you must know that those milliseconds start, however, from 1st of January 1970 at 0 o'clock UTC. So new date is epoch. Here they wanted to create 24 times 3600 times 1000, which means a day after epoch, because you multiply by 1000 milliseconds to get the seconds, you multiply by 60 to get the hours, and then you add 24 hours, so this is January 2, 1970. And you can even use apparently negative dates, and if you use negative dates, apparently dates can go past 1970, but as we do with the BCE, how do you say that? There's something before epoch and something after epoch. And you can also create a date given a string, but the string must be properly formatted and must be some string that the date object is able to parse. So for example, 2021 0313 is a string that is parsed easily. Because it's part of the standard, if you just need a date, you just put a date. If you need instead also the time, you can. Let's say it's 14:15. As you can see, there is a string here that's telling you exactly what we want. If I put z, it becomes 15:15. If I remove z, it shows the date in the current local time. The browser knows what is my current local time, so this date is seen as local. But if I put z, then this is the time according to Greenwich, and it's going to change in local time. It's 14:15 in Greenwich time, it's 15:15 my local time. And what if I write a completely messy date? If I say 13/03/2021, well, this is an invalid date because the format is not good. And what about the American format? Okay, the American format is accepted, which I think is quite racist. No, it's not racist, but yeah, American privilege. Okay, yeah, they have it like this. Americans win. So yeah, you can create dates also starting from a string. And what about formatting dates? Is the new used to invoke the date function with a specific value? Well, the new keyword is used to create new objects. I think that you can create date like this, but I would never suggest you to do that. Const date is equal to date. Date is actually just a string. No, is it not? Date get time? Yep. So if you don't use new, apparently when you call date, it's going to just give you a string. This is a behavior that I didn't know. We will understand better the meaning of new when we start dealing with classes. And I think that we will be able to talk about classes today. It's not that difficult as a concept. We already stumbled upon the new keyword when we looked really quickly at a special function that is called a constructor function. Remember, that was this constructor function. You call the function with new, and this constructor function, as the name suggests, will create a new object of that kind. We don't use constructor functions anymore because we use classes. So as soon as I explain classes to you, this will probably make it easier. The new keyword was optional at first in JavaScript, which is kind of strange. It's kind of stupid too. In any other language, the new keyword is important, and if you miss the new keyword, everything breaks syntactically. But in JavaScript, no, it was not born like this. So sometimes you can you can omit the new operator, but you will see unexpected results. For example, you call date without new, and it doesn't give you a date. It gives you a string that you cannot even use, actually. So don't really care about that string. Okay, so let's see if, okay, there's another way to instantiate dates, which is by specifying all the different numbers. And it's done like this. Come on. Const date is equal to new date, given all the information one by one. 2021 is the year. Then you have to specify the month. And if you want to specify March, it must be 2, not 3. And then the day is 13. And this is already enough to specify a date. The date is 13 March 2021 at exactly midnight local time. Or if I want to add some more stuff, I can edit. Now it's 14/19/00, and I think that's enough. And this shows 14/19/00. So as you can see, you can create dates from the timestamp, from the single values, from a string, but it must be well formatted, or with no parameters at all, and this will be the current date. Get full year, get month, get date, get hours, get minute, get second, get milliseconds. Not get year, but get full year. As you saw, there is some get year is deprecated. as you can see. It returns 2 digits year sometimes. Please never use it. If I look at one date, for example, new date, let's say my date of birth. I was born in 1982, October 17. Ooh, not 61. October means 9 in this case. And what if I say get year? Get year gives me 82. Because before the year 2000, we used to say year 82, not just 1982. Of course, it's 19 something. But nowadays, especially since we are in the year 2000, it's much better to tell apart 1970 rather than 2070. So it's much better to use get full year, which will give you the 4-digit year. And we also saw that if we do this thing with 2082, get full year still works, but get year could give us unexpected results. 182. So get year is deprecated. Never use it. Get day. Oh, get day. We didn't see get day. Get day could seem to be the day, so 13, and instead it's the day of the week. So when was I born? 0. 0 means Sunday. I was born on a Sunday. You can check it out, your day of birth. We can try, what is today? 2021 to, today is the 13th. And it says 6. 6 means Saturday. Because if you start counting the days of the week from Sunday, it's Sunday 0, Monday 1, Tuesday 2, and Saturday 6. You have nothing past 6, of course. You count back to 0 for Sunday. And this is still a very American thing because, for example, Italians start counting dates of the week from Monday, not from Sunday. But yeah, the American wins. But they will never win over the metric system, at least. We've got get hours, but we also got get UTC hours, which will give you the hours in Greenwich, not in local time. We have other things like get time. Get time, we did see it. Get time zone offset. We also have setter methods. So methods that set a property. So if you have a date, you can set a different full year or even a month and a date, apparently. You can set new month. You can set the new date. So you can perform operations on a date before printing it. So if you want to say what day is tomorrow, you set date, the current date plus 1, and then you will have tomorrow. Autocorrection. Okay, apparently there's some autocorrection which I don't really care about. Date to number, date diff, I don't really care about that. We also have date now, which is exactly the same as new date, but date now just gives you the timestamp. So you can, if you want the timestamp of the current date, you can do something like date.now, and it will give you the current timestamp. Or you can say new date get time, which will give you the current timestamp, which is different from before because some time already passed. What else? What else? Now you know how to compare dates, for example, right? You can just subtract the two dates, and now you can have an array of dates, and you can arrange them in ascending order, because you can always compare dates by comparing the milliseconds, the timestamps. Okay, I don't want to go too much in detail on this. You can parse from a string. Okay, so another thing that is quite interesting, you can date from string. Was it like this? No, parse. Date parse, sorry. There is this other date parse. As you can see, this is not new date parse. This is just date parse. And don't worry, you will understand this. Date parse, I think it expects at least 2 strings. Let me check. No. No, Not at all. Okay. Date parse, I'm going to write a string in a standard UTC format, so 2021 03 13. And as you can see, it gives me a timestamp, so this works. And what if I write it wrong? What if I write it in the American format, 03 13 2021? Yeah, it's also understood. And I'm not sure it's exactly the same. Let me check. Yep, exactly this. No, it's not. No, it's a different timestamp. I don't know what kind of date is this. New date of this string. Yeah, not string. New date of this timestamp, and this is the 13th of March, so this is understood. And what about this? New date from this milliseconds. Okay, the only difference is, for some reason, this also gave me the local time, and this instead is Greenwich time. I think that's a bug in the language. No idea. I'm never using dates like this. This is just an introduction to dates. But what I want to tell you is that date parsing, manipulation, and formatting is so complicated that still nowadays probably just using the plain date object is not a good move. We used to have a library, a very famous library called Moment.js. Moment.js is a library that allowed you to easily manipulate dates. You just had to call this function, moment, and then this creates a date, just like new date, and you could format the date in a convention that you specify, in a format that you specify, with a convention that is specified by moment. Or you can easily get the start of the day or the start of the hour, the end of the day, the end of the hour. You can subtract, add days. You can do a lot of things. You can format in different locales. And this was the library for dates manipulation. But there are two problems with this library nowadays. First of all, this library is huge. It's heavy. And it doesn't even use internally the date object, which makes it even heavier because it creates its own date abstraction. And secondly, Moment.js changes your dates, mutates your dates. And as you can imagine, we developers started to really love immutability. If I want to change a date, I don't want to change a date. I want to have a copy of the previous date with some properties changed. And so Moment.js is now even deprecated and discouraged by the same developers of Moment.js. If I remember correctly, there is some place in here, maybe here, project status. Moment.js has been successfully used in millions of projects, and we are happy to have contributed to making date and time better on the web. As of September 2020, Moment gets over 12 million downloads per week. However, Moment was built for the previous era of the JavaScript ecosystem. The modern web looks much different these days. Moment has evolved somewhat over the years, but it has essentially the same design as it did when it was created in 2011. Given how many projects depend on it, we choose to prioritize stability over new features. As an example, consider that Moment's objects are immutable, as I was saying. So we don't really like immutable objects. Another common argument against using Moment in modern application is its size. It's huge. So that's why the same creators of Moment now ask you to stop using Moment. And there's also articles that say you probably don't need Moment.js anymore, or you may not need Moment.js. And there are some recommended alternatives. The recommended alternatives are other libraries such as Luxon, Date.js, Date Functions, DateFNS, JS Yoda, which I never heard before, or there are some new constructs in the date objects that may suit for you if you need to do easy date manipulation. So maybe you don't even need a library. Maybe you can just use the date object. For example, if you want to format the date to your current locale, you can maybe use toLocale string, which is already there. We didn't use it, but new date dot toLocale date string. And this is, no, this is American. What about toLocale string? Okay, I don't know why it's doing this in American, but I think that this is because my browser is localized in English. If my browser was localized in Italian, then it would be different. And I don't know a quick way to turn my browser language to Italian without messing up. So you try new date toLocale string. If your browser is not localized in English, maybe you could have a different behavior here. Please tell me in the chat. I'm doing like YouTubers. Please tell me in the comments what is the result of your toLocale string. And remember to subscribe, press the notification bell, and let's thank our sponsor, Miss Quackers. Did anybody try new date toLocale string? Yeah, I get the same. Okay, so just English. So yeah, there are alternatives to Moment. Right now, for my current projects, I'm using date functions. I'm not saying it's the best, but I like it. It's very lean, and date functions allows you to use only specific functions. For example, format, given a date, and you can format it in any way you want. Or it is even able to manipulate durations, so differences between dates, distances. So this is pretty nice. It's not the only one. I believe that Luxon is another very cool one. Let's see this thing here. Datetime.now set zone America New York -1 week end of day to ISO. So you can create a long chain of calls, which this is method chaining. You remember what I told you last Wednesday, I think. Method chaining. You create a date, and then you create methods that return the same object, so you can invoke other methods on the same object until you reach a point, for example this one, to ISO, that returns something else. To ISO probably returns a string, so you cannot chain anything else anymore. Okay? So this is all that you need to know about dates. Bottom line, dates are complicated, and if you have to manipulate dates, you probably need to use a library. A library not as Moment.js, because nowadays it's deprecated, but a library like those recommended by the same guys at Moment.js. Luxon, Date.js, date functions, etc, etc. I'm using this one. I like it, but it's fine. It's actually the same. Okay. Ooh, there are some things that I already explained to you. For example, you remember the JSON stringify and JSON parse? It was a way to turn a JSON object into a string, a serialized string. And then from that string, you could turn back into an object. So this is something that I already explained. I don't think we need to see anything more than that. You just need to use them. Blah, blah, blah. No, don't really care about that. But please, read this kind of documentation and do the exercises. I'm not doing this because it's not really that important and nothing new, but you are supposed to practice a lot. So this is a lot of work that you have to do on your own or with me during Wednesdays. So this was all that was to say about date and time. Read the reference material and do all related tasks, do related data types, string and array exercises for frequent camp. Write different functions on number arrays that, okay, so lots of homeworks here. If you want, you can try with those array methods like for each, map, filter, find, sum, every, reduce. I don't remember which one they are. You can do things, you can create functions that print all the items. This is pretty easy. Create a new array containing the same numbers but doubled. Check if the array has at least one even number. We probably did it already. Check if all items are even. We did that too. But you can try with odd or any other property of numbers. Return the first even number or undefined. This is something that we already tried. Return an array of even numbers or an empty one. Again, still something that we did. Sum all the numbers together. We already did that. Get even numbers, square them, then add them together. Okay, you know what? This is the exercise that I really ask you right now. I would like you to come up with some function that gets all the even numbers, squares them, and adds them all together. And I would like you guys to try and implement this thing in as many ways as possible. With the for index loop, with the for of loop, or with the for each, with the reduce, with the filter map, or whatever you come up with. Please experiment with this. And there's also a read moment.js documentation and use the library to calculate your age and check if a prompted date is today. I don't know. No, you can skip that. Or if you want to, you can, let's see, moment.js playground. Yep, when I have to deal with these libraries, I usually find a JS Fiddle, which is a web application that allows you to change some HTML, CSS, and JavaScript code on the fly and see the results. And the cool thing about JS Fiddle is that this Fiddle in particular has moments already available to you. So if you want, you can explore the documentation of moment.js. Where am I going? The documentation of moment.js and try to calculate your age with moment.js. Or if moment.js, you believe that it's too obsolete for you to learn nowadays, maybe there is also a date functions playground. Yes, there is one. It's in Code Sandbox, which is very similar to JS Fiddle. It's a place where you can write some JavaScript here. And there's also some CSS and some index HTML. There's probably too much in here. Yeah, way too much. But you can change something in here and you can use date functions. As you can see, start of day is a function that is provided somehow, it's here, and is provided somehow by date functions. This thing apparently also imports Luxon. So if you want to check how Luxon behaves, you see what I did. I just looked for date-fns playground, and the first result that I found on Google was a playground on which I can play around without even knowing how to install a package, how to import a module. I just use things here. So that could be still a relevant and useful exercise if you want to try, or you can do it with moment.js. That's also fine. So you can try to calculate your age as a difference between the current time and the day you were born, or check if a prompted date is today. Well, pretty stupid. Okay, and that's it for data types. There's another part about functions. But what I want to show you here is that actually we already did almost everything about these slides. So recursion. What is recursion? If you look for recursion on Google, I think it's still there. They say, did you mean recursion? So it's a joke. It's an Easter egg. If you look for a recursion on Google, it says, did you mean recursion? Because a recursion is still something that calls itself. Recursion is used a lot in mathematics, and it can be used to create beautiful fractals, like this Sierpinski triangle. And it's also the main reason of Stack Overflows. A Stack Overflow, well, yeah, it's a website, but a Stack Overflow is also a bad situation. Oh, come on. A stack overflow occurs if the call stack pointer exceeds the stack bound. What? Well, it's actually pretty easy. So when you invoke a function, this function is placed into a stack. And now you know what a stack is. It's just an array of things piled up one on top of the other. So the function that you are invoking is placed on top of the stack. And at a certain point, the browser or the computer decides to process all the functions from the first to the last one in the stack. In a LIFO way, in a last in, first out fashion, just like with stacks. I'll never get to the recursive memoirs with so much homework. It's pretty easy if you know what stack and heap are, just saying. Yeah, okay. I'm telling you what stack is. I'm not saying what a heap is because I don't think it's really important. The heap is strictly related to the garbage collector. I see, Bobby, that you really want me to explain what a garbage collector is and even what a heap is. Okay, I can do it. I will do it. If you really want to, I'll make an extra lesson at the end telling you what a heap and the garbage collector are. The stack, you already know what this is. So this should be not a problem right now. A stack is just a collection of elements piled up one on top of the other. And when you invoke, no, it's cool, I'm just messing with you. Okay. So when you invoke functions, these functions are placed on top of the stack and then are processed one by one from the top to the bottom. But if you have a recursive function, it's a function that calls itself. And if it calls itself indefinitely, this function will be placed in the stack. And if the function calls itself, there's another invocation of the function that is placed in the stack. And the stack gets piled up with the invocation to the same exact function until the stack is full and you get a stack overflow. You are invoking too many functions, so the stack cannot use them all. So we have to pay extra attention in recursion because we have to, at a certain point, stop the invocations. And this is nothing new because you already know that you can incur into an infinite loop when you do a for loop. In that case, you're not doing a stack overflow. You're probably doing a heap overflow, but who cares about that? You are doing a memory overflow, okay? And just like you have to avoid infinite loops, you also have to avoid infinite function invocations. What am I saying about function? What do I mean with function invocations? Let's call it functions. So if you say function call me, and this function executes call me, you understand that this function will execute forever doing nothing. Because when I invoke call me, it will invoke call me, which in turn invokes call me, which in turn invokes call me, and that's it endlessly. Instead, if you put some stop condition, for example, call me a certain number of times, that by default is 5. And if the number of times is greater than 0, then call me a number of times -1. Otherwise, don't do anything. Okay, this is a function that eventually will stop because call me with this number is very similar to to a loop that has a variable that starts with a number. I said times 5, but I can start with any number. I can start from 0 and go up to 5, and that's fine. Yeah, that's fine. I'm counting backwards. I'm counting from 5. If times is greater than 0, so I'm invoking call me, but I'm invoking call me on times -1, so 4. And invoking call me, now times is still greater than 0, and at a certain point, times will be equal to 0, so the function will stop. This is a recursive function that at a certain point will stop. And this is the important part. In mathematics, we've got this induction I don't know how's it called. In mathematics, we can prove things mathematically in multiple ways. We can prove things by leading to an absurd if we start from the wrong hypothesis, or sometimes we can prove things by induction, if I remember correctly, which means that there are some steps. I have to get the trivial step, for example, when the number is equal to 0, and then I give for granted that it's true, the thing that I'm going to prove is true for a certain n, and I need to prove that it's true also for n plus 1. In mathematics, we've got this kind of thing. In programming, recursion is really, really similar because we have the trivial step, which is the case in which we want to stop the recursion. And we've got the function performing when we have a generic n. And we also have this n plus 1, which is actually the increment or decrement of that variable that allows me to, at a certain point, stop the recursion. So I don't want to go into detail on the maths because I'm not good at maths and I did this kind of math many years ago, so you probably know better than me. I don't really care about that. But recursion is quite useful for some cases, for some scenarios. And one exercise that I gave to you is actually a pretty difficult exercise, but we can start solving it, solving a smaller problem. The smaller problem is, how do I create a factorial function? The factorial of a number, let me just specify it here. The factorial of a number, factorial of n, for example, is n times n minus 1 times n minus 2, oh come on, times etc, 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 until I reach 1. So for example, the factorial of 4 will be 4 times 3 times 2 times 1. Well, the times 1 is optional because multiplying anything by 1 is not really that important. And it's actually pretty easy to write the factorial function with a for loop. But there's another way to write the factorial function, knowing that the factorial of n, if you think about it, is exactly the same as saying n times the factorial of n minus 1. So you see the recursion? I'm not unraveling all the execution here, all the expression. I'm saying that the factorial of n is something combined with the same function applied to a different parameter. But we have to pay attention because this thing must stop at a certain point, and it must stop when n is equal to 1. So there's another thing that I have to keep in mind. The factorial of 1 itself must be specified in a different way. It's not n times factorial of n minus 1, because otherwise it would be 1 times the factorial of 0, and then 0 would be 0 times the factorial of minus 1, etc, etc. Factorial of 1 is 1. This is the base step. It's what makes our recursive function stop. So factorial of 1 is 1, and factorial of any other n, which is not 1, is n times the factorial of n minus 1. And given this thing, you can write the factorial function in a recursive way, and I encourage you to do that. The exercise that I gave to as an extra challenge for those who really want competitive programming is even more difficult than that, because I'm also mixing the concept of memoizing, which means just caching a partial result that you already computed, so you don't have to compute it anymore. And it's part of what I'm explaining in these slides. In fact, I don't even want to explain these things. I want you to come up with this kind of behavior. So recursion, as you can see, is not a new part of the syntax. It's just one way you could use functions. And it's one way you could incur into a Stack Overflow, of course. Closure. We already talked about closures, because you already know that a variable declared on the browser, like this one, let a is equal to 1, this is a global variable because it can be accessed from the global scope. But if instead I write this variable inside of a function, let's say function hello, let b is equal to 1, even if I execute this function, b is not accessible from outside. This is the concept of closure, almost there. So when you see code like this, you see that let name is equal to Pete will be visible to this internal function because it's defined outside of the scope of this function, but name will not be visible from outside of the make worker function because it's declared inside of the scope of this function. And this is what closure is about, nothing at all. In fact, I see let name is equal to John, but this variable has nothing to do with the variable called Pete. It's completely different. And the alert here will alert Pete instead of John. But we already talked about this, right? So with functions, you can even do something like functions that hold some values and return other functions. This is probably the strange thing. A function that doesn't just return a value, it returns a function that you can then invoke, which is pretty interesting. You can do pretty cool things. So for example, it's an advanced concept, so don't worry. Let's go back to two simple functions. What about a sum? Function sum, given a and b. We return a plus b. Nothing new. But sometimes I can write functions in a different way. For example, I can have a function sum that takes only one parameter. And it cannot compute any sum if there's just one parameter. In fact, I'm going to return here another function from it. So it's a function that returns another function. It's what we call a higher order function because it's not just a function that returns a value, it's a function that returns a function. And as we can return a function, we can have functions that return a function that returns a function that returns a function that ultimately returns a value. You can go as deep as you want. If I write the function like this, it's plain JavaScript. It's nothing new from what I already explained to you. It's something that probably you never thought was possible. But it's not a new syntax element. It's just a new recipe, we could say, a new strategy, a new way to use the concepts that we already know. The difference here is that this first sum can be invoked like this, sum of 2 and 3. And this other function is invoked in a slightly different way. You have the sum of 2, and this is the first parameter. But when you invoke this function, this will return another function. And you know what? I'm going to save it to store it into a variable. I'm going to call it sum2. Sum2 is equal to whatever comes from this sum2. And now sum2 is not a value, but it's a function. It's the function that was returned from this first function. And so since it's a function, it expects another number, which is, for example, 3. And this will give me the final results. I can console log the results, and it still gives me 5. So as you can see, the way we invoke these two functions is slightly different. This first function just takes 2 parameters and returns immediately the value returned by these 2 parameters. So this is just 5. When I invoke this function, sum of 2 instead, this is not returning a value, it's returning a function that returns a value. So this is just returning a function, and sum2, once I store it in a variable, will give me 5. So I'm delaying the computation. And this allows for cool things that probably it's best not to tell you right now, because we are 6 minutes before the end of the lesson, and I think that we already put a lot of meat on the barbecue. And I also see Bobby's returning is easy. Remembering what the function returned is what is hard. Yes. But as you can see here, this could be a hint to the solution. I saw your latest solution, which was just a function that contained the cache and returned the result. You probably want this kind of function here. You want a function that contains the cache and returns a function, which is something similar to what you already did before your latest solution. So you are almost there. You have to combine two different concepts and merge them together. You already have a function that returns a function. You already have a function that uses a cache. Now you need both, a function that uses a cache and returns a function. And you can do it. So this thing here, if you transform a function of two parameters into a function that returns a function and gives the same result, this is what we usually call currying. Not because we are adding curry, it's not Indian food, but because there was a guy called Curry that created this thing. Currying. Currying. Mathematics and computer science, currying is the technique of converting a function that makes multiple arguments into a sequence of functions that each take a single argument. Blah, 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 blah. Let's see. You know what? Yeah, there's Haskell curry. In fact, there's also a language called Haskell in honor of Haskell curry. And sometimes at university, I even heard this currying thing as Schönfinkelization, because, well, there's also Schönfinkel who developed this thing. Introduced by Frege, something like that, developed by Schönfinkel and further developed by Haskell curry. So currying is pretty cool. And it's an advanced concept that a lot of expert JavaScript developers do not know. But as soon as you learn it, you will have another very, very cool superpower that I will show you next Saturday. As for now, I think that we've done way too much. Just a quick recap on this set of slides, however. These are all advanced concepts of functions, on functions. Recursion, we already pretty saw it. Closure, we already pretty know how the scope of variables work inside of functions. This is closure. Hoisting, you already know what hoisting is. If you use the var keyword, then the variables are not belonging to the scope of the block, but are belonging to the scope of the whole function or the whole file. That's why you don't want var, you want to use let, because you don't want the variables to be hoisted, but you want the functions to be hoisted. So sometimes you prefer function declarations. Global variables, you know what a global variable is, so we are not going to spend any more time on this. And the function object, which is something completely irrelevant. I'm not going to even explain this to you. And finally, there are some functions that allow you to schedule tasks, defer tasks, or even do tasks from time to time. This is something that we can see next time. It's actually pretty easy, especially if you understood the concept of callback functions. And that's it for today. 5 hours. Quite a lot. Great marathon. Thanks a lot. I believe that you are pretty tired. I must confess, I'm tired too, but also happy because you stayed till the end. If you have any problems, please ask me on Discord, as always, or ask anybody else on Discord. And feel free to bother me anytime, because you're not bothering me. You're bothering more when you don't bother me. So feel free to interact whenever you want. I'm still sharing the Discord link. Yeah, I'm myself. What is this? I want to copy the link. Okay. So if you want to join Discord, please do. And see you next Wednesday for our practice session. I don't know how much we will be able to do since there are lots of exercises there. And then let's meet next Saturday if everything goes well. In the meantime, have lunch, please, or have dinner, whatever. Eat pasta and code faster. Bye.